Hello, everyone. I'm audible. Okay, so fine, guys. Good afternoon. So I think I'm audible to everyone. Yeah. So let's start with the class. Okay, Pranam Dipender, how are you? I'm good. And today is going to be an exciting day for all of us. We are going to discuss so many things in today's class. So yeah, let's start. Okay, so I believe my screen is visible to all of you, right? And let's launch this decision tree. So, okay. So I'm assuming that you all are ready with your Jupyter notebook, right? And we are going to start. So I think there was some disruption and there was some disturbance last week, and we were not able to continue, and we have to discuss so much things inside our decision tree. So let's try to talk about this in a very, very depth, right? So this is how we are going to do this thing. So you play PUBG, right? No, I never played actually. So maybe I have just installed. So maybe someone has given me a recommendation, and I have just installed and kept it. So it's been like a more than 8 to 10 years since I played any game in my system. Congratulations to new office. Thank you so much. Okay, so now today it is going to be a back-to-back. Yeah, so be ready for that. So first of all, let's try to import each and everything. And I believe we all are aware about a data set. In today's class, we are going to visualize a decision tree. We are going to prune a decision tree. We are going to understand a multi-class classification confusion matrices as well. We are going to see many internal things and internal observations from a decision tree. So that will be an idea, and that is the objective of today's class. So yes, be ready, and so many lines of code we are going to write in today's class. So be ready for that. So try to increase your typing speed a little bit. I think it will help you out a lot, right? Otherwise you will not be able to perform a practical operations, practical examples inside a class. So after a class, then you will have to spend some time, and then at the end of this class, so I'm going to make again one amazing announcement for all of you. Yes, but at the end of the class, not now. Okay, so fine, let's try to understand. So same data set we are going to consider a wine data set. I think we have started with wine data set, we have not completed yet, right? So we are going to start from the same point with respect to a data set, a wine data set, and then we can try to conclude. And many more things, many internal things we are going to see, because this data set is a kind of a huge data set, and you will be able to see that it's like a little bit difficult in terms of even visualizing those data set, or in terms of maybe understanding those data set, that how it is going to form a decision tree. So we'll try to work on that part. Yes. Okay, so let's start. So yes, at the end of my class, I'm going to make an announcement for all of you. Now, so let's try to import pandas. So yes, guys, start typing without wasting a time. Pandas as PD, and then import NumPy as NP, and then maybe from sklearn. From sklearn, so we can try to import a tree. Yeah, so we can try to import a decision tree out of this one classifier first of all, and then from sklearn, from sklearn, so we can try to import maybe just a tree. So import tree, and then from sklearn, so we can try to import maybe a model selection, or dot model selection. Okay, so we can try to import maybe a train test split, and then maybe a grid search CV to find out a best possible parameter. So we can try to import even a random search CV. That's completely fine. So grid search or random search, anything is fine. So from sklearn, so scale not image. So from sklearn, so we can try to import maybe matrices. So matrices and the matrices wise, so accuracy score we have to check, and we have to check confusion matrices for multi-class classification. So confusion matrices I can try to import, maybe ROC curve we can try to import, and yeah. So and then maybe we can try to import pandas profiling, and we can try to import maybe a profile report out of this one. Yeah, so we can try to import these many number of things. So hope we all are good, right, with respect to our import. So this is the same import that we have done in our last class, and then we are going to import our data frame, and our data frame is nothing but pandas.read CSV, and we can try to import this one and data frame.head. So I believe this is good. We have already discussed about a data set. It's a simple one where we are trying to classify what will be a quality of a wine, right, if these input parameter is given to you. So if these input parameters are given to you, then what will be a quality? Total number of classes over here is equal to 6, right? So I can try to identify that as well. So maybe I can try to do df dot quality, and maybe we can try to run we can try to run a set operation on top of this one. So here is a class 3, 4, 5, 6, 7, 8, right? So this is a class that we have. Total number of classes is equal to 6. So it's completely fine. We have 6 classes in this particular place. We can try to run some sort of a profile report if we want. So we can try to maybe import a profile report, and then we can try to pass our data frame, and it is going to give me analysis of all the data. So whether my data set is skewed, whether my data set is not skewed, how many null values are there, how many zeros values are there, right? So many different kind of informations we all will be able to get, right? Some of you are saying that please provide a code. So this is a same code that I have discussed, but still I'm pinging you in your chat box. So here it is. So it is now available inside your chat box, right? So this is a code that we already have. And wait for my announcement, guys, at the end of the class. Yes, it is going to be like a amazing announcement for all of you for sure. So I just repeated more than 4 times, I believe. Okay, so yeah, a data set is available to all of us, right? And we are able to run a profile report, and I believe we have already discussed about this profile report in our last class, right? So let's just get started with so are we supposed to discuss about the profile report, because we have already discussed, right? No, yes. So I'm not able to understand why you're saying no or yes. Maybe I have asked a question in a wrong way. Okay, already discussed. Okay, so a quick glance. Okay, so see, profile report, as we all know, I'll just like try to repeat myself. So it is going to be a same version, right? So in last class we were talking about a profile report, and we all know about a profile report, what kind of output a profile report always try to give you. So it always talks about like what is a nature of your data set for a particular column, whether your data set is a categorical one or it's a numerical one, or so whether your data set is skewed or non-skewed, what is the total number of attributes, what is the total number of records that you have, whether you have some sort of null records or maybe a zeros record you have. So each and everything you will be able to see. So we have multiple columns like a fixed acidity. So here we have approximately like a 96 distinct value and 6% distinct value, which accounts for a 6% of distinct value. Number of zeros is equal to 0. So we don't have any zeros value. We don't have any kind of a missing values. I believe in none of the columns, so we have any kind of a missing values. Plus, if you would like to understand a nature of the data set, so it's more like a normal distributions that we are able to get. So again, even if I'm not going to run maybe a standard scalar, or if data set dispersion is approximately same, so maybe I don't have to do a standard scalar in this particular case, and I can like I'm like a good to move. I'm like a good to move ahead, and then I will be able to build a model, right? So yes, this is like a normal distribution data set that we have. That's completely fine. If I'll talk about a column called as volatile acidity, so in that case, again, we don't have any kind of a missing values. We don't have any kind of a zeros values, and it's again a normally distributed data set. Not able to see your screen, is it? Visible, right? Everything is fine. Yeah, so yeah, everyone is confirmed, so it's clearly visible. Okay, so maybe you can try to log off and log in again, but my screen is visible. Okay, so if I'll talk about a residual sugar, so again, missing value is equal to 0, zeros is equal to 0, kind of skewed a little bit. So not much, but yeah, kind of skewed, you can say. Again, we have a chloride column, normally distributed, no missing values, no zeros. If I'll talk about a free sugar dioxide, so again, no missing values, no zeros, and kind of little bit skewed on the right hand side. It's completely fine. Total sulfur dioxide kind of skewed right hand side, right? Missing 0 and 0 is 0. Then again, if I'll talk about a density column, so it's completely normally distributed data set that we have, no missing values and no zeros. pH scale values, if I'll talk about, so again, normal distributed data set, no missing, no zeros. Sulfate, no missing, no zeros, and normally distributed almost. Alcohol, so this data set is a little bit skewed on right hand side. And if I'll talk about a final column, so we have 6 distinct value, which is a quality column, which is representing a classes. So our classes is available in a numeric format, right? But still it's a categorical data set because just a numerical categories which is given to me. And I have already shown you right here. So this is the total number of class that we already have over here. Fine. So these are the little bit interpretation of the data set that we already have. The rest of the interpretation, I think we all will be able to understand. So what is a correlation? So just by looking into a Pearson graph or maybe a Spearman or maybe a Fick test. And yes, so we have discussed about these things a lot in our previous classes with respect to almost all the data set. Fine. Now what I will do is, so I'll try to prepare my X and Y. So my X is going to be all of these columns and my Y is going to be this quality column. So feature and a label. So my label is going to be a quality column and my feature is going to be the rest of the column. So it's completely fine. So if I have to create maybe X values or X data, so we can try to write df dot drop and then we can try to drop what? So we can try to drop column CO. So yes, column, and we can try to write down over here quality. So quality column we can try to drop. So now we have a X data and we have a feature data, I can say. Okay. Now we have a feature data over here. Then we can try to create Y values. And if I have to create a Y values, so this is nothing but it is going to be my data frame dot quality. So this is going to be my Y values. So this is completely fine. I have a Y values over here. So I'm able to get a Y and I'm able to get my X. I'm able to get my feature and I'm able to get my labels in this particular place. So there is no issue with respect to our labels and there is no issue with respect to a feature. This is pretty much normal for all of us. Now, what is the next step that we are going to perform? So if we are not doing any kind of a data pre-processing, right? So if we are not trying to handle some sort of a missing values, if I'm not trying to handle some sort of a standard scaling, or if I'm not able, if I'm not trying to handle some of the zeros values, or if I'm not going ahead with the imputations, which is a part of your data pre-processing, or if I'm not going to create some of the derived column out of the existing one, or if I'm not going to accommodate some of the third-party data over here, which will be important and which we are going to do, but not today or not in these classes. So maybe in our previous classes or maybe in our upcoming classes. So we will try to accommodate our third-party data as well. We'll try to create some sort of a derived column based on the business case understanding. So here, if I'm not going ahead with any kind of a data pre-processing step, so in that case, I can directly jump into a model building, right? So if we have to build a model, so maybe I can try to do a train and test split. And I think we all are aware about it. So train test split, I can try to call, I can try to pass X and Y. So my feature and my label, I can try to pass over here. And then, so I can try to pass my test size. So maybe I can try to provide test underscore size is equal to maybe 25 is to 75. So 25% my test size, and maybe my train size is equal to 75%. And random state, if I would like to keep, so yes, I can try to keep random state underscore. So why it is not giving me auto completion? Train test split spelling is correct. XY, this one is fine. X comma, this is fine. This is fine. Random state is equal to 30. A random number we can try to keep. Fine. So this is going to split my data set, as you can see, in X and Y. So X test, Y test, and then X train, Y train. So in this way, it is going to separate my data set. Fine, no issue. So here we can try to store this data set into X underscore train, and then X underscore test, and then Y underscore train, and then Y underscore test. So these are the 4 data set that I will be able to get. So X train, X test, Y train, and Y test I will be able to get over here. Fine. X test, and here we have 1199 number of records, and in case of our test data set, so we have 400 number of records. So approximately we have 1599 records, and we have just done a split operation out of this 1599 records. So in train as well as test, so that I will be able to keep some of the record for a testing purposes, for which I know our final classes. But in real time, what happens is, so this is our approach that we try to follow just at the time of building a model. But actual test will be done on a random data set. So client is going to resolve some of the data set, or they're going to provide you a real-time inputs. And then with that real-time inputs, your model is going to do a prediction. And then they try to create, or they try to prepare a final evaluation matrix or evaluation data set. And based on that, they will try to compare prediction and your actuals. So they always try to keep some sort of a data set which is completely unseen to your model. Again, extra data set we are not utilizing. So again, we can consider as of now that this is a unseen data set for my model, if I'm going to build a model only on my test train data set. So is it fine for all of you? Yeah. Okay. Fine. Moving ahead. So this is like some pretty much basic. So we can try to build a decision tree model, right? So we can try to build decision tree model over here, and we can try to call decision tree classifier. As of now, we are trying to solve a classification problem. Decision tree also solves your regression problem. So it's not like decision tree just solves a classification. Decision tree solves your regression problem as well. But as of now, we are just working on this classification problem. There are so many different kind of values which is given to me, like a CCP alpha, which is used for your finding out the complexity. And again, many more things is given over here. So one by one, we will try to understand each and everything, and then we will try to test it, that what kind of an improvement we are going to do. But before that, so we are supposed to build a base model. Fine. So this is a model object that I have created. Now, if I have to train my model, so in that case, what I will do, so decision tree object, right, dot, I can try to fit my data set. So X underscore train, I can try to fit, and Y underscore train, I can try to fit over here. Now here, so your model will be done, and your model will be built in this particular place. So once your model will be built, I don't know what kind of a tree system has created internally. So if I would like to get some sort of a glimpse of it, right, if I would like to see that what kind of a model my final decision tree has created internally, right, if I will be able to visualize this entire tree, I believe it will be easy for me to understand. And again, we all will be able to correlate our understanding with a theoretical concept. So again, we have discussed like a Gini, we discussed about the information gain based out of entropy. So somehow, right, somehow if I will be able to visualize it, my work will be done, right? So my work will be done. Someone is saying that we did not do a multi-collinearity check here. No, we are not trying to do a multi-collinearity check over here because decision tree is trying to divide a data set. It's not like we are working on the regression problem. So if we are working on the regression problem, that may affect, multi-collinearity may affect, but here, so we are not trying to do the same thing. Yes. And again, there are so many different kind of improvements that we can do. So in a later stage, maybe we can try to check, right, Vinod sir? I think you got your answer. Overfitting for X train, it's giving 100% accuracy. No issue, Sugam. So that's the reason. So this is not the end of your class, right? I just started. I'll talk about it. Today I'm going to discuss about these things a lot, right? One by one. Okay, so then I'll take a questions. Okay, so now let's try to visualize first of all, because from a visualization, so I believe you will be able to get so much of idea and understanding, and then we can work on this part. Fine. So to visualize this decision tree, so maybe I can try to import simple sklearn. I believe we have already done an import. Okay, not just a sklearn. Fine. We have to do some sort of an import over here. So we can try to import maybe sklearn as it is, just a pack. Then we can try to import maybe a matplotlib, matplotlib.pyplot, same old way. So import plt, and then from sklearn, so we can try to import from, I think we have already done an import of sklearn tree, import tree, and then maybe I can try to write matplotlib inline. So matplotlib, so that I can visualize my result. So invalid. Okay, so from, fine. Okay, sorry, it's a alias, right? So import as plt, it's alias. So this is the import that we are supposed to do. So it's a simple matplotlib import that we are trying to do, nothing much or nothing else we are trying to perform over here. Then what we can do is, so maybe we can try to plot figure. So plt dot figure, we can try to call, and then we can try to set maybe a fig size. So maybe 20 cross 20, a bigger one, right? If we are expecting a bigger tree, so bigger picture, it is going to give it to me. And then we can try to call tree dot plot tree. So tree is an import that I'm trying to do from sklearn, right? So this is just an import that we are trying to do. We all are trying to do. Again, this one is not going to work if your sklearn version, or if you are using a old version of a sklearn. So maybe you can try to check that what is a version of your sklearn. I believe all of us will be able to check it, right? So you have to check first of all what version of sklearn that you are using. So if I have to check what version of sklearn I'm trying to use, so in that case, simple underscore version, and this is a version which I'm trying to use. So if you are using 23 or above, it is going to work. Otherwise, it is not going to work. Fine. Now here, so once we are able to understand that, fine, this sklearn version is available above 23, so it's completely fine. 24 or maybe a latest version is going to work fine for all of us. Now what we can do is, so maybe we can try to call tree.plot tree. And what is our tree object that we have created? So anyone? So what is the tree object that we have created? So can I say that this is a tree object, tree model that we have created, right? So dt underscore model, fine. So I'll try to pass my model over here, fine, and then execute. So it is going to take some time because it is going to produce each and every values, plus it is going to give you a final graph of the decision tree. So it's a very, very easy concept, and in the easiest possible way, you all will be able to get a graph. If your system is slow, or maybe if you're using maybe an old version of your system, it is going to take a little long time. Fine. So now if you will scroll down here, you will be able to see a decision tree. So this is my decision tree, and it's not a colorful one, right? It's not a colorful one. So if I'm looking for like a colorful decision tree, so maybe there is one parameter called as filled. Filled is equal to true. And now it is going to give me a colorful decision tree. So just wait for some time. Again, I have just executed. Okay, so now I have a colorful decision tree, and this is a tree my system is able to build based on the data that we have given to this particular model. So I didn't got any tree, so just wait for it. Once it will be able to complete its execution, so you all will be able to see a tree over there. So this is a final tree. Now, if you start looking into this tree, you will not be able to understand anything, because the problem is, it's like font size is very small. Plus, these boxes are very, very small, right? So we are not able to get any idea that what kind of a tree it has created. Yes. So we are not able to understand, or we are not able to see this entire things, and where it has done what kind of a split, based on what criteria, based on what Guinea values, or what is there inside a leaf node, or maybe what is there in between a branches. And yes, so my observation will be incomplete. So yes, for sure, you are going to need a telescope, right? So if you have to observe these things, maybe even after that, you will not be able to observe, because our data size is very, very huge. And it has ended up creating a very huge or big one, a big tree, right? So maybe what I can do is I can do these things for you, that we can try to take maybe a smaller data set, and then I can try to create a decision tree, right? So maybe a subset of the data set I can try to consider, and then I can try to create a decision tree, which we will be able to visualize, plus we will be able to understand what is the meaning of each and every node. Because inside this node, you will be able to see some sort of a write-up, some sort of a text, which is very, very important in terms of understanding a decision tree. So fine, let's try to do that. So here is a data frame that we already had, right? Original data frame. And maybe I can try to select a couple of records out of this one. So maybe data frame dot head, and then I can select only 30 record as of now. And we can try to create maybe a data frame one, right? Data frame one. And then based out of this data frame, or based out of this data set, so I can try to build a decision tree, and then I can see what is the like a kind of or nature of the decision tree that we already have. So fine, let's try to do that. So here, what we can do is, so we are not going to even do a train and test split. This is just a sample tree which I'm going to draw, or which I'm going to create. So this is my 30 data set. Now df1 dot, I have to create x as well. So x1 is equal to df1 dot maybe a drop, and then we can try to write columns is equal to quality, and then my y1 is going to be df1 dot quality. Fine. So x1 and y1, and then we can try to create a dt underscore model 1, and this is nothing but a decision tree classifier. We are going to build this object, and then we can try to do decision tree underscore model 1 dot fit, just to understand this decision tree and visualize this one in a better way. So we can try to pass x1 and y1. Like I said, so I'm not doing any kind of a train and test split. So this tree we have built again based on the smaller data set. And then we can try to perform a similar kind of a operation. So let's try to perform a similar kind of operation. This time I'm going to give model 1, right? And then let's try to see. So I believe this time this decision tree is clearly visible, right? All the text. Yeah. So we all are able to see this decision tree very clearly. I have taken a very small data set, just a 30 record I have considered. And then based out of that, I'm trying to build this entire decision tree. If I'm going to consider a whole data set, this is a tree that you will be able to understand, or you will be able to get. Again, we can handle it. We can handle this one. So if we have to stop our tree maybe on a level 2 itself, level 3 itself, that is possible. And that we can do, that we all can do. So this is what I'm going to teach you in a tree pruning approach. So how we are going to prune this entire tree, maybe a post pruning, maybe a pre pruning. But yeah, so when I have considered a very, very small data set, so this is a decision tree which we are able to build. Now try to understand all of these things. So whatever we have over here, so try to understand these particular part in a very first place. What is the meaning of this x1 or x2, x6, x6? Guinea sample, or maybe Guinea sample, or this value. So what is the meaning of these values? Let's try to understand that particular part. Before that, so let's try to understand. So we had y1, right? We had y1. Inside y1, how many classes was there? Because we have just selected a 30 record, that there is a possibility that I don't have a 6 classes. I have maybe a lesser number of classes over here. So maybe I can try to fire a set. So how many classes we have inside my small data set subset? So in total, we have 4 classes, right? So in total, we have 4 number of classes over here. That's completely fine. We have 4 classes. So here, if you will try to understand, and when I was trying to build a decision tree, right? So can I say that I have considered criteria is equal to Guinea, right? So we all have considered criteria is equal to Guinea. So it is trying to calculate a Guinea impurity, and whichever is having a lesser Guinea impurity, so it is trying to divide that particular, it is trying to divide a data based on that particular condition. So fine, Guinea value is equal to this much. Sample is equal to 30. Can I say that we have considered 30 number of sample, 30 number of records? Yes. So this is what this sample is trying to denote. So here you will be able to see a sample. So what is the meaning of the sample? Sample is nothing but total number of samples that you have considered in a first stage. So total number sample is equal to this one. What is the meaning of this value? So meaning of this value is nothing but we have 4 classes, right? So we have 4 classes, and what is our class name? So 4, 5, 6, 7. So these are the 4 classes that we have. So here it is trying to tell you that, okay, we have a 4 classes and total number of record is equal to 30. So our class is equal to 4, 5, 6, 7. So here when we are trying to perform a split operation, or whenever we are trying to split an entire data set, so we have 1 values from class 4, 21 number of values from class 5, 5 records from class 6, 3 records from class 7. So if you will try to combine all of these three, so 21 plus 1 plus 5 plus 3, it will be equal to a total number of samples that you have. It will be equal to 30, right? So it is going to be a 30. So in total, we had 4 classes, class number 4, class 4, class 5, class 6, and class 7. So these are the total number of classes that we had, a unique classes that we have had inside our data set. And value always try to represent that how many values we have from a particular class. So from class 4, we have 1 values. From class 5, we have 21 number of values. From class 6, we have 5 number of values. From class 3, we have, from class 7, we have 3 values. So in total, we have 30 number of values. This is what our values denotes. So is it clear to all of you? Yes. So what is the meaning of values? What is the meaning of sample? What is the meaning of Guinea? Okay. Now, so what we are supposed to do is, so here, so at this point of a time, so yes, these are the 4 separations it is able to create. Now here, so it is trying to perform this one on X2. So what is the meaning of this X2? Anyone who can tell me? What is the meaning of X2? What is the meaning of X2? So if I'll ask you a question maybe in a different way, on what column it is trying to perform our separations? So which column is a parent node over here? So can I say that third column 0, 1, 2, right? A third column, so whatever is the column, I believe it's a volatilic acid, right? So for volatilic acid, it is able to find out what? It is able to find out Guinea impurity is a minimum Guinea impurity, because it will calculate a Guinea impurity for all the columns. And I think we all are aware about it, how to calculate a Guinea impurity minus of P log of summation of Pi, square. So we all know how to calculate a Guinea impurity. So here it is going to calculate a Guinea impurity for all the columns. Now Guinea impurity is less or minimum for which column? A third one, or it's a volatilic acid column. Then it is trying to make a separation. So whatever data we have inside this column, lesser than 40.42 will go on this side. Greater than 0.42 will go on this side. Is it fine? Okay, I believe it's a citric acid. So whatever is the third column, simple. Like I don't remember all the column names. So I think we all are able to understand that part, right? So it's completely fine. Whatever is the column name. That's the reason. So I'm referring to a third column because I don't remember column name. That's completely fine. So here we can say that on third column means x2, second index column. So it is trying to make a separation. So whatever data set we have inside this column, lesser than 0.42 will go on this side and greater than 0.42 will go on this side. Is this thing's fine to all of you? Yes. Okay. So how this 0.42 will be decided? Maybe on an average, or maybe it's a mean of this entire things. Yes. So based on that, it will be able to decide. Fine. So here, let's suppose if I'm going to plot this entire data set again. So DF1, we have a very small amount of records. So maybe we can try to, yeah, it's a citric acid, right? So here, if you will try to find out the average of this citric acid, I think you will be able to get your answer. So based on this data set, so it is trying to divide this entire things. It is trying to divide this entire thing. So the very first parent has been created based out of which column? Citric acid column, this column, third number column. Okay. So hope this idea is clear. Guinea is clear. So what was the Guinea value when it was trying to divide? So for sure, for rest of the column, Guinea values will be higher over here. So now it will try to divide my data set lesser than 0.42, greater than 0.42 based on these column values. Okay. Now what we are trying to do is, so again over here, so we have to make a division because now we have two subset of the data set, right? Our data set which is having a values lesser than 0.42 in a citric acid column and greater than 0.42 in a citric acid column. So if it is trying to divide my data set, so 26 data set is having lesser than 0.42 values. 26 number of data set is having lesser than 0.42 values, and 4 data sets. So because 26 plus 4 is equal to 30 over here. So 4 data set is having greater than 0.42 values. I think you can cross check because we have a very small data set, right? So just try to calculate which all data set we have which is having more than 0.42 as a value. So 1 and then 2, 3, 4. So yeah, can I say that we have only 4 records where citric acid value is more than 0.42? Yes. So I think we all are able to validate. We all are able to validate this one. This is what happens when you work with a smaller data set. So you will be able to do a better interpretation. And when data set will be bigger, so you won't be able to do a better interpretation. That's the reason. So we need a machine learning model, right? But yeah, with a small data set, so it's easy for us as a human being to perform these kind of operations. Okay. Now here, right? So here we are trying to perform these kind of operations, and on right hand side and left hand side, so it is able to divide my data set. Now again, when it has divided my data set on left hand side and right hand side, so here we have 26 data and here we have 4 data. Again, it will try to perform a split because we have 2 data frame, one on this side, one on this side. So here again, can I say that it will try to calculate a Gini for each and every columns? Yes. So it will try to calculate a Gini for each and every column. So we know this is saying that mean for citric acid is 0.18. So it's not exactly a mean it is going to consider. So you can even try to set this value, divide kind of a value. Otherwise, it is going to take somewhere a random sample and then it is going to divide. So that is also possible. Okay. So here this time it is going to perform this separations based on 7th column, right? So X6. So lesser than 22 values will go this side and greater than 22 values will go this side. And again, this is representing a class. So in this 26 data set, we are having one data set from class 4. Then from 5th class, so we have 21 data set. Then from 6th class, we have like a 2 data set. And from 7th class, we have a 2 data set. This is the meaning of it. Again, a same meaning over here. And on this side, so again, it is trying to like divide the data set. So here from class 4, we don't have any data set. From class 5, we don't have any data set. From class 6, we don't have, we have 3 data set. From 7th classes, we have a data set over here. Fine.
So it will be able to make a separations in this particular place. Now again it is trying to make a separation. So here we have 26 data set, and lesser than 22 will go this side, greater than 22 will go this side. Based on this time 6 means index is equal to 6 means seventh column. So based on the seventh column value, so again it is trying to divide my data set. So greater than 22 will go this side and lesser than 22 will go this side. Fine. So when we are trying to make a division again, so we are able to see 4 samples over here, 4 data set over here, and 22 data set over here. So 22 plus 4 is equal to 26. Fine. And again, same thing, Gini for everything, it will try to calculate. And again, here it is trying to define a parent. So it is again trying to find out a Gini for each and every columns. So for X6, it is going to find out. So we are trying to make a repetitive, we are trying to create repetitive parents from the same column, because each and every time it is trying to calculate a Gini for what? Gini for all the columns, because it is trying just to make another data frame each and every steps. That's it, right? A subset of the data frame it is trying to create, and then based on that, it is trying to divide it. Same as our calculation that we have done in a manual way. Fine. So here we have a sample 4, we have a 22 sample, 22 plus 4 is equal to 26 over here, meaning is same, class 4 0, class 5 1, class 6 1, class 7 2, then class 4 5 6 7, and here, so when it is trying to divide my data set again, so now Gini is equal to what? A 0. So if Gini is equal to 0, so I believe there is no impurity, or maybe a minimum impurity is equal to Gini impurity is equal to 0, that we are able to find out. So fine, this. So here, can I say that in this particular place, what is the class that we are able to observe? What is the final classes that we are able to observe? So 4, 5, 6, 7. So can I say that this node is going to give me a 6th class, and this one is giving me a 7th classes over here? So can I say that this is going to construct a leaf node, a final decision making node for all of us, or maybe a label node, I can say, right? Ideally it's called as leaf node. So it is going to construct a leaf node in this particular place. A very simple thing. Now here on this side, on our left hand side, it will keep on dividing again and again and again, unless and until it is not able to construct, or it is not able to reach out to the leaf node. So everywhere you will be able to find out that here is a leaf node, 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 here we have leaf node, because the rest of the things are 0. So it's not possible to divide it further, because now all of the data set. So let's suppose here we have 18 data sets. But can I say that all the 18 data sets available to us are from the same classes? So here we have all the data sets, and all the data sets are from where? So all the data sets are available from basically same classes. So it's completely fine. We don't have to worry about it. And even we can try to print a classes. So it's not like we won't be able to print the classes. So we can try to print a classes. The simple thing is you have to convert your numerical value into a categorical value, or maybe into a string values, and then you will be able to print this classes as well. So Nilesh has pinged me this one. Even I was like supposed to write this code, but yeah, as he has already pinged me, so maybe we can try to write it down. So if I would like to see a class name, so maybe we can try to execute it again. And can I say that we all are able to see a class name? Class is a new value that we are all able to see. Class is equal to 6, class is equal to 5, class is equal to 5, class is equal to 5. So can I say that our interpretation was correct? Yes. So finally, we have only one record, which is representing class 7. We have 18 record over here. So total number record is equal to 18. But all these 18 record are representing class 5. So do we are we supposed to divide this decision tree further? No, right? We are not supposed to divide this decision tree, because if we just have only one data set from only one classes, it's completely fine. So there is no further division which is required in this particular cases. And yes, we are able to see our final classes in the easiest possible way, right? So here, if you have a numerical data, so how to print this class name? So if you have a numerical data, let's suppose y1. So what is my y1? So my y1 is nothing but my entire classes. This is my y1, right? Then what you can do is, so you can try to extract this entire y1 data. You can try to extract this entire y1 data. Then you can try to find out the unique of this one. So we are doing a set, and then you have to convert this entire data set into a list of a string. Because if you are going to provide a numerical, it is going to give you an issue, because this is what it says. So here, if you will check a definition of this this one, so there is a parameter called as class name. By default, it will be none. And if you will check over here, so it is telling you that list of the string. So you are supposed to provide your class name as a list of a string, then only it will be able to print. Otherwise, it will not be able to print. It's a nomenclature of the function which is given. So you are supposed to convert all of your classes into a string, and then you can try to pass it on in an ascending order. Simple. So fine, you can try to like do that. You will be able to perform these kind of operations. Again, feature name is another parameter that you can try to provide. So feature name is equal to nothing but x1.columns. You can try to provide. So here you can try to provide feature name. So x1 dot maybe columns. You can try to provide over here. Now you won't face any kind of an issue in terms of readability. So can I say that our interpretation was correct in a step-by-step manner? So even we are able to see a citric acid, sulfur dioxide, right? Sulfur dioxide, total sulfur dioxide, free sulfur dioxide. So now we are able to see even a column name, right? So each and everything is possible. It's just about like how you are going to pass a parameter. That's it. Each and every parameters are available. Even if it is not available, it's completely fine. We can try to do a interpretation. So these are the total, these are the whole idea behind this one. Okay. So we can try to perform these kind of operations in the easiest possible way. And I believe, so the tree, the kind of a tree that we are able to construct, so we all are able to understand it, right? Everyone? Yeah. Okay. Someone is saying that please show a code. So see, this is the code, but again, this is not tough. Whenever I'm not able to understand some sort of a code, because yeah, there are like thousands of method and functions. So it's like really impossible for a human being to remember each and every function. So what I do is I always do like a shift and tab, and I try to check the parameter. And then I try to check over here that, okay, fine. So what is the meaning of this one? Feature name, list of the string we are supposed to provide. So fine. I'll try to provide a list of a string. If it is not available, I'll convert it. Class name, list of the string we are supposed to provide. If it is not available, I'll try to convert it. So it's not like you're just supposed to do a copy and paste. You can try this out even from your end, and you can do it easily, right? So fine. Here, feature name is equal to my data set x1 dot columns I'm trying to provide, and yes, it is able to print each and everything. So this is what I do all the time. So even for me, it's not possible to remember all the parameter. For none of us, it's possible to remember. Yeah. So I believe we are able to understand this particular part. Now someone is saying that how we can try to download this one. So if I have to save this decision tree, right? So how I will be able to save this one? So no issue. I think we can try to save it, right? So I can try to save it. So this is a PLT figures which is given to me. So maybe I can try to call PLT dot save fig. Maybe we can try to give some figure name. So maybe dt underscore model underscore, I can give any name, maybe 1, right? And then I can try to save it. So fine, it will be saved somewhere inside my directory, decision tree. Where is a dt? Okay. So yes, a beautiful picture I'm able to see, I'm able to get it, right? Out of this decision tree. I can try to save it. I can try to paste it maybe inside my Excel sheet representation if I have to give a representation to someone. Yes. So till this point, I believe it's completely fine for all of you, right? Okay. Fine. So hope we all are able to understand. And yes, I'm able to show you with respect to a small data set. But yes, as your data set size will grow, it will be impossible for us to showcase these kind of things. So maybe we can try to work on this decision tree, and maybe we can try to understand that how we can restrict a growth of this decision tree. So let's suppose, right? So let's suppose this is a decision tree that we are trying to create, and on one side, so on this right hand side, it is able to grow just till a second node. So 0, 1, 2 till second point, it is able to grow itself. But if I'll talk about maybe a left hand side, so on left hand side, so 0, 1, 2, 3, 4, and even it is going till a fifth step, right? So even it is like it will keep on dividing a data set unless and until it will not be able to get into a final separations. So here, just try to observe one simple thing out of random observations. So here, can I say that from class 5, so we have a 20 record, and from class 1, we have, from class 6, we have only 1 record. Can I say that over here? Just a random data or random node I'm trying to pick, right? So can I say that I have a 20 records from class 5, and I have 6 number of record, 1 records from class 6 we have in this particular node. So can I say that even if I'm not going to consider these things, it's completely fine. We have majority of the data set available from one of the classes. Class 4, 0 data set. Class 7, 0 data set, right? We have majority of the data set available here from this one, from class 4. So just from the class, class 5. So we have a majority of the data set. So even if we are not going to make a division or unnecessary separations or creation of a new node, so can I make a statement over here that I will be able to reduce a complexity of this decision tree? And it's completely fine, right? I have a majority of the data set, so it's completely fine. Everywhere we are able to see class 5, class 5. Just in one case, we are able to see a class 6. I think it's not that important, right? So maybe on other side, it will be able to consider this 6, and then it will be able to give me an answer. But again, whatever data set is coming to this particular node, majority of the data set belongs to a class 5. So maybe in future, whenever I'll make a prediction, I can try to make a prediction as a class 5th prediction. So in this case, can I crop this entire growth of the tree just to remove or just to reduce the complexity of the model or complexity of the decision tree? So yes, maybe we can try to do that. And that is something called as post pruning. So first we are trying to build a tree, then we are trying to observe, and then based out of that, so we are trying to perform some sort of a pruning operations. Maybe we can try to remove this one so that my decision tree will be crisp, short, and precise. My complexity will be less, and I will be able to make a prediction in a better way. Yes, maybe with respect to an accuracy, I can try to do some sort of a compromise. There is no issue with that. But at the same point of a time, if I'm able to reduce a complexity, it's a added advantage for all of us. So this is something that we all can do. Okay. So now let's try to do that. Let's try to perform some sort of a pruning operation. Let's try to find out what is a meaning of a pruning operations, how we can try to perform a pruning operations, how we can try to find out some sort of a parameter which can help me out in terms of doing a pruning operation. Anyhow, going forward, we are going to perform what? We are going to perform a best possible parameter fine tuning, which is called with the help of grid search CV or maybe a random search CV. But as of now, my idea and approach is very simple. So I'm supposed to do a tree pruning in such a way that it will not try to grow itself if data set is very, very less from one of the classes. So that's my idea over here. So it's completely fine. We can try to do that. But before that, so maybe we'll have to check or we have to perform some sort of a accuracy. So here I have not taken any kind of a test data set. Here I have just taken a single data set X1 and Y1, And then based out of that, I'm trying to build this entire decision tree. If I'm going to check this decision tree with respect to some random data set, then we can try to observe what will be the accuracy. So fine guys, let's try to check what is accuracy score, what is a training accuracy, or what is a testing accuracy that we have over here. And then maybe we will be able to build a better relationship. Yeah. So fine, let's try to do that. So how, any idea? So how I will be able to check accuracy, train and test accuracy if I have to check? Yes. So maybe we can try to do some sort of a prediction, and then we can try to check what is the accuracy score, right? Or maybe I can try to pass these things into a accuracy and I will be able to know. So fine, let's try to do it. So first of all, what I can do is, so maybe I can try to pass some sort of a data set. So DT, and then this is the model one dot predict. So now I'm going to pass which data set? So maybe a same data set which I have given at the time of training. So fine, this is the data set that we have given at the time of training. And with respect to our same data set, I'm trying to do a testing, or maybe I'm trying to do a prediction as of now. So this is a test accuracy I'm trying to calculate as of now. So fine, here what we can do is, so maybe we can try to calculate DT dot and DT underscore model dot score, and here we can try to pass x1 comma y1. So what is the accuracy? 100%. Now let's try to provide another data set over here. So DT model 1, and if you remember in our beginning, so we have already separated some of the data set as X test data set. So maybe that random sample I can try to pass over here, because that test data set is just a random sample, right? And Y test I can try to pass, and then we can try to check what is the accuracy. So what is the accuracy that we have? 44%. When I'm trying to check these things with respect to a random data set, so it is giving me 44% accuracy. And when I'm trying to test it, so with the training data set, so yes, it is giving me 100% accuracy. Can I say that it's kind of a overfitted model? Right? It's kind of a overfitted model we have built. It's completely fine. Even I was expecting overfitted model, so that I will be able to tune it. I will be able to perform some sort of operations, right? And then my train and test accuracy, I'll try to bring it down closer to each other. Okay. So what is my next goal? My next goal is to bring this train and test accuracy closer to each other in such a way that, yes, this model is not going to be a overfitted model. Your accuracy is less, that is not an issue. But if your train accuracy and test accuracy is having a huge amount of differences, that's an issue. And it is always going to create a huge amount of an issue. So let's suppose you have said that okay, fine. So I'm very confident with respect to my model. And yes, it is giving me like a 90% accuracy. And when person is going to test it with the random sample, with the random data set, and at that point of a time, it is giving me like 50%, 60% accuracy, lesser than your actual one, I can't accept that model. But if you have claimed that, okay, fine, so my model accuracy is 60%, and then 60%, 65, 62, 59, 58% accuracy, in that case, yes, it is completely fine. I can accept that particular model, but I won't be able to accept a model so which is having 100% accuracy at the time of training, and then a very less accuracy at the time of testing. So we will not be able to accept it. So it's completely fine. Let's try to like do that, and let's try to understand. Okay. So here, what we can do is, so maybe we can try to perform some sort of operations, maybe some sort of tuning operations we can try to perform, and then we can try to build this entire decision tree, and then we can try to check that what is there and how we will be able to like tune, or how I will be able to perform maybe a post pruning of a decision tree. So what we can do over here is, so maybe we can try to call decision tree model 1 dot cost. So cost, complexity, pruning, path we can try to call. And then we can try to pass our x1 and a y1. So original data set, so whatever data set that we have taken at the time of training of the model. So maybe we can try to take this data set and then we can try to store these things maybe inside a path variable because it's a cost, complexity, pruning path. It's called as CCP. So it's called as CCP. So we can try to calculate a CCP's alphas from here. Okay. So now what is it going to give you? So if I'm going to print this path, so this is the value that I will be able to get. So it is giving me CCP alphas value starting from 0 till this point, and then it is giving me impurity, right? So then it is giving me impurity. So here you will be able to find out that the CCP is nothing but it is representing a complexity, a cost complexity of a pruning. So if we are going to prune, then what will be a cost complexity? And pruning means nothing but, so we are trying to remove our leaf node. So some of the leaf nodes, some of the branches, we are not leaf node, means some of the branches we are trying to remove. So this is something called as a pruning. Now, how I will be able to utilize this data? How I will be able to, because CCP alpha and impurities I am able to see or I'm able to get it. That's not an issue at all. So CCP alpha is equal to 0, and by default, if you will observe, your CCP alpha will be equal to 0. So let me go back to this one. And then if you will try to check, by default, your CCP alpha is equal to 0. Now, what is the meaning of it? Like I said, so it is going to tell you about the complexity. Yeah. So class weight CCP alpha, a non-negative floating point number, complexity parameter used for minimal cost complexity pruning. The subtree with the largest cost complexity, then is a smaller, then CCP alpha will be chosen. So by default, CCP alpha we are trying to set is equal to 0. It simply means that it will be able to build a infinitely grown tree. So as long as it will be able to divide a data set, it will keep on growing, or it will keep on creating a branches. But let's suppose we are going to keep CCP alpha, some of the CCP alpha values as a threshold. In this case, it will try to check each and every time that, okay, what is a cost of complexity of this particular branch that I have grown? So if cost of complexity will be more than the cost of complexity that you are going to set, it will do what? It will try to remove that particular branches. So this is how it is going to do a pruning operations with the help of cost complexity parameter, right? CCP alpha. So that's the reason. So it is going to give you the alpha that, okay, fine. So when we are trying to divide our tree, so what is the cost of complexity that we all are able to see, or we all are able to get over here? So fine. The question is how I will be able to utilize these values. So no issue. Let's try to utilize these values, right? So we already have CCP alpha value. So maybe I can try to extract CCP alpha value out of this one. So CCP alpha, CCP underscore alpha is one of the parameter I can try to create. And then this is nothing but path dot CCP alpha. Okay, so let me check what is the data type. It's basically a dictionary. So we are supposed to pass a key and then I will be able to get our values. Okay, so it's a dictionary. So maybe I can try to write it down in this way. I can try to provide a key. Okay, I think it's alphas, right? CCP alphas. Okay, that's a key. So fine, I'm able to see, or I'm able to extract only a CCP alpha because it was just a dictionary. So yes, I'm just trying to extract it. So I have just passed a key and I'm able to see our values over here. That's completely fine. You all are able to get it. Even this will work because if it is a key, so dot CCP alphas. Yeah, so it is going to work. Okay, so in both the way, it is going to work for me. So CCP alpha I'm able to extract. Now what I can do is, so maybe I can try to print CCP alpha versus accuracy, train and test accuracy. If I'm able to find out that, so based on that, maybe I can try to perform a pruning operations, or I will be able to decide on which place I'm supposed to perform a pruning operation. So let's try to do that, right? And I think CCP alpha values you all will be able to understand, because this one is very, very important when it comes to a pruning of a decision tree, or maybe creating a model which will be a balanced one, which is not going to overfit in any circumstances. So what I can do over here is, so maybe I can try to perform some sort of operations over here, so where we can try to do some sort of a prediction, or maybe I can try to plot some sort of a graph, so where I will be able to observe at what CCP alpha values I have a same accuracy from a training data set, as well as I have a same accuracy from a test data set. So maybe I can try to perform these kind of operations. So it's fine. We can try to calculate maybe a train score. So my train score is nothing but what is the model that we have built. So I believe DT model 1. This is the model that we have built. So my train score is nothing but this one dot score. And here, so I can try to pass what? My X1 data and my Y1 data. Same data which I have used for a training purposes, right? Okay. So this is something, and I can try to write for I in. So for this one is the model for I in, maybe this CCPs I can try to build, or this is a little bit like a complex code. So first of all, we have to calculate decision tree. So maybe I can try to create a decision tree underscore model to number of a decision like a last tree. For I can say CCP underscore alpha in CCP alpha that we have already taken, or I can try to keep it as CCP itself. So we can try to write DT underscore model is equal to maybe a decision tree classifier, and then CCP alpha is equal to CCP. Yeah. So what we are trying to do is, so we have so many CCPs over here. We are able to receive from this decision tree, where we are able to get like so many different kind of a cost complexity. So one by one, instead of passing a 0 CCP alpha, starting from a 0, so one by one, instead of passing a 0 CCP alpha, what we can do is, so we can try to pass a different CCP alpha over here, a different computational cost we can try to pass over here, and then one by one, so we can start building a decision tree. So that's the reason. So we are trying to go through each and every value. So we'll try to build a decision tree with 0. Already we have built a decision tree. So here, when we are trying to build a decision tree, so we are trying to build a decision tree with CCP alpha is equal to what? 0. Right? So CCP alpha is equal to 0. So what we will do is, so we can try to build a decision tree with a different CCP alpha values, and then we can try to test which tree is going to work fine for me. Because if we are going to build one just decision tree, if I'm not trying to compare, I will not be able to decide that which tree is better and which tree is worst. So because already we have built a worst tree, our training accuracy is 100%, but our testing accuracy is 44%, which is a completely overfitted model. So I'm just trying to control it with the help of CCP alpha. So for CCP alpha 0, CCP alpha 1 point something or 2 point something, 0.20, something like that. So I can try to give, and then I will try to build a decision tree, a multiple decision tree, and then I can try to test it. And this is what we are trying to do over here. So fine, for each and every CCP alpha values range, so we are trying to build one by one a decision tree, and then we are trying to fit data set. So X1 and Y1, same data set we are trying to fit. So X1 and a Y1 data set over here. and then inside our like DT model 2, so we are trying to append. So we are trying to append what? So we are trying to append our model. So we are trying to append our model, decision tree model we are trying to append in this one. So in this list, I will be having a multiple models. Can I say that over here? A multiple decision tree model we are trying to create with our different values of CCP alpha. Okay, fine. So it's completely fine over here. So we are able to create a multiple model in this particular place, execute it. This is completely fine. Now here, so if you will try to check your decision tree model, so how many decision tree model that we have built? So can I say that we have built a decision tree model with CCP alpha is equal to this, CCP alpha is equal to 0 by default, CCP alpha is equal to this. So multiple models that we have built over here. In total, 1, 2, 3, 4, 5, 6, 7, 8. So in total, 8 number of model we have built so far, so forth. It's completely fine. Now, which model I am supposed to select out of this one? A model which will be a less overfitted one. Agree, everyone? So can I say that I'm supposed to select a model, right? I'm supposed to select a model which is having a less overfitted result. Yeah, you have already built a 8 model. Again, I'm just talking about one parameter. Likewise, there are so many parameters as you can see, right? So here I'm able to build 8 model from the same data set. But what I have done over here is, so I have considered a different CCP alpha values, right? Cost complexity parameter I have taken as a different one, because cost complexity parameter always creates a threshold that, okay, so if cost of some branches is more than this threshold for this decision tree, in that case, I will not create that branches. I will not allow that branches. I'll just remove it. So are you able to understand the meaning of this CCP? Yes. So whenever in your interview, if person is going to ask you that, okay, fine. So how you're trying to do a pruning of the decision tree, you can simply say that yes, at least you can talk about one of the parameter called as CCP alpha. So you can say that okay, so we try to set a threshold of cost computation parameter and cost complexity parameter, and if complexity of building any branches inside a decision tree will be more than that, automatically it will try to prune it, right? Automatically it will try to remove it. It will not try to take this one. What is the range of CCP alpha? So you can try to take a range of starting from 0, because by default CCP alpha value is equal to 0 till maybe 1, 2, 3, 4, right? So in between that, for that range, you can try to test it. So we have considered some of the we are trying to find out some of the CCP alpha's values, possible alpha values, and then based on that, so we are trying to do it, which is relevant to this particular decision tree. Again, in case of our grid search, so we are going to perform the same thing. So we'll try to find out the best CCP alpha values, even with the help of grid search. So this is just one of the way which I'm showing you. There are other way as well to find out the same thing. Okay. So here we have this CCP alpha's values. Now what we can do is, so maybe we can try to perform plotting operation, CCP alpha versus train and test, right? So let's try to perform some sort of a plot operations based on this one. So are we all able to do it? Yes. Okay, fine. So once we all are able to do it, so Nilesh has pinged me this code by which I can try to draw this entire tree. Okay, S is not defined. So what is the S value that you have taken in line number 10? Line number 10. So plot S. Okay, so what you are trying to plot, by the way? It will be score. Okay, iteration. No. So I have some different graph. I'll just show you. This is not going to work, because what I'm trying to do is I'm trying to compare train and test. So what CCP alpha values I'm supposed to select? So can I say that I'm supposed to select a kind of a CCP alpha values where train and test accuracy is same? Yes. So wherever train and test accuracy is approximately close to each other, that kind of a CCP alpha values I'm supposed to select, so that it will not create, or it will not end up creating a overfitted model. This is the expectations that we already have. Okay, no issue. So maybe we can try to perform that kind of operations. So let's try to do that kind of operations one by one. So first of all, I would like to find out a training accuracy. So if I have to find out a training accuracy, so how I will be able to find out a training accuracy? Any idea? So can I say that model.score, and then I can try to pass what? So I can try to pass my x1, y1 values, and I will be able to get a train accuracy. Fine, everyone? Yes. So if I have to find out train accuracy, yes, I will be able to find out a train accuracy. If I have to find out a test accuracy, so yes, I will be able to find out a test accuracy. Now here the thing is, how many models that we have built? We have already built over here. So we have built total number of model is equal to 8. No issue. So I will try to go through a model one by one. As you can see, this is the list of the models. So first model, then I'll go to second model, then I'll go to third model, then fourth model, and so on. So I'll try to go through each and every model. So maybe I can try to write it down in this way. So for I in, this DT model 2 that we have created, right? One by one. So let's suppose I'll go through the very first model, and then I can try to check. So what will be the value of I? So can I say that value of I will be nothing but this model? Yes. Okay. So fine. One by one, I'm just trying to go through this model, and then I can try to check I dot score. Right. So I dot score, and then I can try to pass maybe x1 data set, and then I can try to pass my y1 data set, right? And then I can try to keep it inside the list, so that I will be able to get a score, a training score for this model, this model, this model, this model, this model. A training accuracy I'm trying to find out for each and every model. Is it fine to everyone? Okay. So maybe I can try to store these things as a train underscore score, right? Train score is done. We are able to find out a training score for all the 8 model. Then in the similar way, maybe we can try to find out a test score, right? So again, I can try to write in this way for I in, right? I in a decision tree model that we have, and here, so I dot score, and here, so I can try to pass what? I can try to pass maybe a different data set. Maybe I can try to pass some sort of a test data set over here, which I have created for a different use cases, the use cases which I was trying to build, but tree size was very, very huge. So I have taken a subsample, but yeah, I can try to use that data set for a testing purposes. So X test and maybe X underscore train. X test and then Y test. Y test I can try to pass over here. So it's completely fine. I will be able to get what? A train score, and then I will be able to get what? So I will be able to get a test score. It's completely fine. So this is the training score, and this is the test score I'm able to get, or I'm able to see. Okay, no issue. Then what we are supposed to do is, so we are supposed to plot a graph. We are supposed to plot a graph where we are supposed to see some sort of a relations with respect to a train score, test score, and a CCP alpha, because we have built a multiple models, right? We have built a multiple models, and for every model, so we are trying to find out a train score, and for every model, we are trying to find out what? So we are trying to find out a test score. We are supposed to select that CCP alpha values where train and test score is almost closer to each other. This is something that we all are supposed to find out, or this is something that we all are supposed to do. So here is a code that we all can try to use. So maybe we can try to use this one, plot. So this is a plot that we all are able to see. So here, training size, set size you have given. So is it correct? Training set size, X label. No, so it's not going to be a training set size, right? So trainer score, Nilesh has paid me again this code. So trainer score, texture score, Y label is equal to a decision tree score, train, and this one. So it will be a CCP alpha first of all. No. So fine, we have like a CCP alpha over here. I'll just ping you this code. This code is nothing but I'm just trying to do a plot. So here set title, set title, set title. So all this like a 4-line is already clear to all of us, right? And here we have a trainer score, and here we have a test score, and then we are supposed to pass like a CCP alpha value. So for train and plus test. So we are trying to combine a multiple graphs over here. That's it. And this is the only thing that we are trying to do over here, nothing else. So we are supposed to pass these two values over here. So like a CCP alphas, and then we are supposed to provide a value. So CCP alpha, what is my variable name? CCP alpha, ALPHA. Okay, so I can try to provide CCP alpha over here and CCP alpha over here, execute. Now this is the graph which I was expecting. So now if you will look into this graph, and if you can try to observe this particular graph, you will be able to find out that maybe over here, when CCP alpha value is beyond this line, maybe somewhere over here, this is closer. If I'm going to consider CCP alpha is equal to 0, in that case, can I say that I have a huge difference in between my train accuracy and my test accuracy? My blue line is representing a train accuracy, and my orange line is representing a test accuracy. So test accuracy is approximately close to 0.44, and then 0.5 somewhere, and then this much. If CCP alpha value is this, right? So this is something that we are able to see. If we are going to change some CCP alpha values, so in this case, it is going to change, or it is going to come closer. So maybe if I can select some like a more CCP alphas value, I will be able to get closer and closer. There is a very, very high chances that if I'm going to select some other CCP alpha values. If you have observed, so what we have done over here, so we have taken first of all a 30 sample, and we have created a decision tree. 30 sample out of 1500 plus sample that we have considered. So for sure, this is not going to understand, or this is not going to have a common, or this is not going to give you a very common relationship out of the whole data set. So we have taken a very small data set. And then at the time of testing, what we have done. So can I say that at the time of testing, so we have taken a data set from the original data set, 1500 records. Yes. So can I say that yes, this was expected? We are able to come closer a little bit. So it's not like we are not able to handle it. So even in this worst situation, so when our trained data set was very, very small, and it was not capable enough to derive the whole relationship, but still we have considered those data sets, right? And at the time of testing, so we are trying to provide some sort of a subset of the data set from the whole data set, original data set. So can I say that we are able to come closer at least, right? So here we have a huge differences, but can I say that here we are able to bridge a gap? we are able to come closer. We are able to reduce a difference between train and a test accuracy. Yes. So fine. We are able to come closer and we are able to bring closer this train and test accuracy. Now, if I'll try to perform a same operation with respect to original data set, you will be able to see that my train and test accuracy is coming even closer to each other, right? So can we say that there is a data imbalance problem? No, we can say that it's not a data imbalance problem. It's basically like a data set is very, very small, and the data set that you have taken at the time of testing, right? So that data set is again holding a kind of a relationship which we have not even learned or which we have not even seen. So if you have built a model, it doesn't mean that it will be able to give you a prediction for each and everything. Because if that relationship was not at all available at the time of training, so how it will be able to give you some sort of a result at the time of testing? So for sure, your accuracy will go down in that case. So we can say that it's because of insufficient, like we don't have a sufficient amount of the data set, and just because of that we are able to see these kind of differences. So in this case, what is the solution? We don't have a sufficient data set. Many people say that my train accuracy is this much, my test accuracy is this much. Fine, if I'm going to consider CCP alpha is equal to more than this, in this case my train accuracy will be equal to 0.7, my test accuracy will be approximately 0.4, right? I'm able to bring down like a little bit closer. That's completely fine. There was a 60% of differences previously, now there is a 30% of differences, so it's completely fine. I'm able to improvise my model, but again there will be a limitation, right? So on the data set on which I'm trying to test it, so that data set was nowhere close to the data set with which I have built a model, or the relationship was not at all available. So in this case, yeah, it is not going to perform well. So can I say that that solution can be to provide a more data set to this one? Yes. So maybe I can try to provide more data set. Fine, no issue. This time what I will do is I'll try to increase a little bit of data set. Many of you say that, and many questions I generally receive that, okay, so my model is not working fine or this or that. So I have taken 30 data set, right? Now this time I'll take 120 data set. Now let's try to execute. Can I say that my train and test accuracy is coming closer? I'll just increase the data set a little bit, right? So my train and test accuracy is coming closer to each other. The idea was to create a model which will be a robust one. Like I said, if you are getting a less accuracy, that is not a major problem. But if you are getting a kind of accuracy where there is a huge difference between training and a testing accuracy, that's a problem. Yes. So that is a problem that you will be able to see. So huge accuracy is not at all a problem, but or maybe a less accuracy is not at all a problem. Difference is an actual problem that you are supposed to solve in a very first place. Because if you are getting 90% of accuracy, it's completely fine. It doesn't mean that you have built a very good model. No, not at all. So how well you are able to understand the relationship, that's mattered a lot, right? This model is bad, that a random guess. Yeah. Now I can try to increase maybe a data set little bit more possible, right? So let me try to increase this data set is equal to 500. Are you able to see the effect? Yes. So I believe all of you are able to see the effect over here. Now my training accuracy and testing accuracy is almost in sync if I'm going to consider CCP alpha values, right? A cost complexity parameter values may be more than 0.1 or in between 0.1 to 0.01 to 0.02, if I'm going to take this one, maybe it is going to work for me. What will be a default CCP alpha values? Our default CCP alpha value is going to be 0. Means, so cost will be like at minimum, what will be the cost? At minimum, what will be the complexity? 0, right? So by default, we always try to build any kind of a like our tree, this decision tree classifier will try to build a model with cost is equal to 0. So whatever branches will be having cost more than 0, yes, it is going to build it. That is completely fine, right? That is completely fine. But if we are going to control a complexity just a little bit, right? Just a little bit. So maybe in that case, it is able to come closer. So this is the effect that you will be able to see. So sometime if you are able to get some sort of a overfitted model, and if someone is going to ask you a question that how you have handled that situation, I think you have an answer now. And you all have experienced that. So what we are trying to do over here, we have increased our data set. Because the problem with the model is, maybe my model is not having that kind of relation. It was not able to understand that relations, right? So if I'll try to increase a data set, so I'm giving a flexibility to my model to adopt all kind of a relationship at a time. And just because of that, so yes, it is working fine. CCP alpha is just a hyperparameter. Likewise, there are other 10 hyperparameter which is available inside a decision tree. So yes, hyperparameter or post pruning is going to work. That is true. It's working for us, right? But what will be my first solution? My first solution will be increase our data set size. It's not like if I have 10 record, I will be able to build a model. So some people say that in case of a decision tree, even if you have a lesser amount of data set, you will be able to build a model. So is it possible? Is it true completely? Not completely true. When we say less amount of a data set, so if you are trying to compare 1 crore record with respect to 1000 record, so for sure 1000 will be very, very less. So we have to quantify over there. So less means what? Less means what number? Less means are we talking about 1, 10, 100, 1000, 10,000 with respect to what volume of the data set? 10 million record, 20 million record, trillion records, right? So many people say that decision tree works well with respect to a lesser amount of data set. I simply ask them a question. Have you seen this kind of an effect anywhere? Or how you are saying that less? Less means what? 1, 2 record, 10 records, is it going to work? No. It is not going to work. Because it's a model. Model is trying to do what? It's just trying to understand your entire relationship. And if you are trying to pass a data set at the time of testing, which was not available at the time of training, it simply means that model is not able to understand that relationship. It has not even built a tree based on that. So now if you are going to give some data set which was not even in the range, it will give you a wrong accuracy. It will give you a wrong prediction. So your accuracy will go down. Yes. Okay. Now, overfitting is a most common problem. Yes. So I think we have an answer. Now, this is the one of the answer to remove the overfitting. So I can give you another 100 different answer by which you will be able to remove overfitting. So this is just one of the scenario, one of those situation, one of those scenario I'm trying to discuss with all of you as of now, right? In one day, hundreds is not possible. I think that's the reason. Yeah. So we'll learn. We have to learn so many things, right? So we'll learn as we will progress. Okay. Now, please show the code. I'll ping you. Don't worry. And anyhow, this will be available. Fine. Not able to copy. Fine, leave it. So as of now, just try to focus over here. Once you will be able to understand the concept, coding is nothing. You're not supposed to type each and everything. If you are able to understand, it's completely fine. So I believe understanding should be a first priority. Okay. Now, so we are trying to increase our data set, but now let's try to look into, right? See this time how many trees we have built. We are trying to compare so many trees we are trying to compare over here. Now what we can do is we can try to look into our decision tree. Can I say that complexity of decision tree has increased? Depth of the decision tree has increased. Now we are facing some sort of a difficulties in terms of like reading out those values, how it is trying to like create a branches or what it is trying to do internally, right? No issue. It's completely fine. We have observed over here that when CCP alpha values will be in between 0.01 to 0.02 or maybe beyond that, right? So my model training and test accuracy both will be closer to each other. So what is the next step? So can I say that next step will be to build a model again? Right? We have so many decision trees, so it is a bagging. Bagging is a different concept. We have so many decision tree because we are trying to test it with a different CCP alpha values because we don't know which is going to work fine for me. That's the reason. So I'm trying to do experiment. And then I will try to get into a conclusion. This is what we are trying to conclude over here. That doesn't mean we have built hundreds of decision tree as we have built over here that it will become a bagging. Bagging is different. I'll show you that as well. Yes. Okay. So now what is the next step, guys? We are able to find out that at CCP alpha in between 0.01 to 0.02, we have this decision tree. So can we say it is as a hyperparameter tuning? Yes, it is a hyperparameter tuning that we are trying to perform in a manual way. And then we will try to perform hyperparameter tuning with the help of libraries called as random search CV or maybe grid search CV, grid search cross validation or maybe random search cross validation. So my next step will be to build a model with what CCP alpha values in between. And then again, we can try to test it. So fine, we can try to do it, right? This is what we are looking for. So maybe this time again, I will try to build a model. And this time I will try to build a model with this CCP alpha values. So fine, let's try to do it. So maybe decision tree model CCP with CCP. I'm just trying to give a name. So decision tree model CCP and then decision tree classifier, capital D, decision tree classifier, random state maybe is equal to 0. I can try to keep as of now for splitting, and then I can try to keep CCP alpha values. Now, what is the values I'm supposed to select, guys? 0.01 to 0.02. So what is the value? Maybe I can try to select something like 0.011. Yes, or maybe 4. Let's suppose I'm going to select. Yes, okay. CCP alpha values. Fine. Now again, I can try to. What was the model name? Like CCP, right? Okay. So model, then CCP dot fit. Yeah, and then x1 and then y1 data I can try to give over here. Fine, I can try to give over here, and then I can try to find out maybe an accuracy. So fine, this is the model that I have built with random state is equal to 0. Okay, so maybe we can delete this one. So fine, this is the decision tree that we are able to build. This time what we have done, we have utilized and we have tuned one parameter. That is what? A CCP alpha parameter that we have tuned over here. And then we are able to build this decision tree. Now, what I will do is, so maybe I can try, so I'm able to build this decision tree. That is completely fine. I would like to know, or I will try to compare between a previous decision tree graph and this decision tree graph. So fine, let's try to do it. So plt dot figure, I can try to call plt dot figure. We can try to define maybe a figure size over here. Fixed size equal to 20 cross 20. I generally give, so fixed size is equal to 20 cross 20. That is completely fine. And then we can try to call like a tree dot plot tree, and then we can try to provide maybe a model name. So what is my model name? Decision tree CCP. This is the model that I have built after doing a hyperparameter tuning, right? And I can try to give field is equal to true so that I will be able to get some sort of a colorful graph. Otherwise, it will give me like a black and white graph. Okay, execute. Now, this is a model that we are able to build after performing hyperparameter tuning. And after setting up CCP alpha is equal to 0.14. Now, which model is more complex? This one or this one? Both of this model we have built on top of the same data set, right? So if you will see over here, so we have built this model based on X1, Y1, same data set, right? X1, Y1, and we have built this model even on top of the same data set, right? Even on top of the same data set, X1 and Y1, same data set we have used, not a different data set. The only difference over here is I'm trying to use a pruning method over here. I'm saying that whichever branches is having a complexity more than this, do one thing, remove it. Because I have observed something over here, that if we are going to perform some sort of a pruning operation, my train accuracy and my train test accuracy is going to come closer to each other. So fine, we can try to check even in terms of numerical numbers, numerical values. So what I'm supposed to do, decision tree and then model CCP that we have created dot score, and what I'm supposed to write over here. Yes. Guys, participate. X1, Y1, what is the accuracy? 59.6, right? Decision tree underscore model CCP. And here I'm going to pass what? X test. And then Y underscore test. Y underscore, I believe it was Y test, right? Okay, it was like it should be a score, right? Yes, score, okay. Can I say that now both is closer to each other, even train and test? So can I say that I'm able to remove overfitting into my models? And we all are able to understand what is the meaning of overfitting. And we are able to know what is the solution, possible solution that I should try out. Yes. So can I say that we are able to solve one of the problem at least? Yeah. So this is something that we were expecting. So like I said, if you are getting a very good score and you are saying that your model is very good, no, that is not a reality. If you are able to build a generalized model, which is going to work in the similar way with training and testing data set, unknown data set, that is something called as model building. So maybe you can write this code on a LinkedIn. So model is, you can try to phrase it in your word, right? So if accuracy is very high, so that is not a model that we should finalize, or maybe that is not a very good model. And if accuracy, train and test is like closer to each other, that is something called as stable model. That is something called as model building. Yeah. So bias and variance, should we check within check? No, it's completely fine, right? So bias and variance trade-off, it's completely fine. So we can try to avoid it. So as we are able to get like a stable model, right? So we can try to avoid it. And this is a tree that we are able to design this time. Simple, right? Very, very simple. Yeah, you're not a good model builder if your accuracy is more. X1 and Y1 is training set, right? No, X1 and Y1, when is training set? Are you like sleeping or something? X1 and Y1 I have created, which was a sample data set, right? So initially I have taken 30, then I have taken 120, then I kept it as a 500. So maybe when you will revise and when you will go through this lecture again, so and when the sheet will be shared with you, you can try to execute and you will get to know. Yeah. X test and Y test is something which I have created initially, which was kind of an unknown data set to this one. On a whole data set, we are getting a still smaller tree. Yes, on this data set, we are getting a smaller tree. So what we have done, this was a tree that we have created where all the branch was trying to expand itself, right? All the branches was trying to expand itself. Whether it is going to make some sense or whether it is not going to make some sense, it will keep on calculating a Gini. It will keep on doing a split. So it will never stop, right? it will keep on doing a split, and it is not going to stop unless and until it will not be able to find out what one single class is. I think we have discussed that part when I was talking about like a smaller tree, when I've shown you what is the meaning of Guinea, what is the meaning of values, what is the meaning of samples, right? And what is the split meaning of split, what is the classes. So we all have seen that particular part. Yeah. So in this decision tree, it will keep on dividing itself. Now we are trying to restrict it. We are trying to prune it, that no, if you are trying to expand this branch, why you are expanding this branch if you are going to increase my cost complexity more than the value which I have given to you. So I have taken 0.014, right? So if cost complexity of this particular branch is more than that, it will just try to remove that branch. It will not even create it. And that is the reason, right? That is the reason. Generally, we say that pruning means we try to chop off the branches. See how we are chopping off the branches? So this is called a chop off the branches. How CCPs are calculated? See, CCPs, you can try to take maybe a range of the values. It's just a parameters, right? So as of now, what I'm trying to do is I'm just trying to generate the possible CCPs values over here, right? But in general, in an ideal situation, what you can do is you can try to take a random number, a series of the random numbers starting from 0, because CCP values always start from 0, means complexity. Even in ideal cases, complexity will be equal to 0, a minimum complexity. It is not going to be a negative one, right? So you can try to start from the 0, and maybe you can try to test it with 2, with 10 number, 20 number. Start from 0, try to test it with 1, in between 0 to 1. There will be so many values, maybe 0 to 5.05, right? So this is something called as hyperparameter tuning. Don't build a model with high train accuracy, they build a model with the compatible train and test accuracy. Yes, Vishal. Yeah, decision tree after pruning. So after pruning and before pruning, decision tree, you are able to see. Okay, fine. Now, so what we can do is, so here we are able to build this simple decision tree. There's no issue with that. What is the next step that we all are supposed to perform? So maybe we can try to perform a couple of more steps. Maybe we can try to draw a confusion matrices. How many of you understand a multi-class confusion matrices? Binary class is fine, true positive, true negative, false negative. I think we all understand that part. I have already discussed in a beautiful way in my class, right? But how many of you are actually understands multi-class? Because I've given you one task, right? In logistic, I believe, one versus rest. Those who have not completed a task, for sure they will not be able to understand multi-class classification of confusion matrices. Practical is easy to understand. Will be better start the practical first, then back-end theory, so that terminology will be easy to understand. No, if I'll start talking about the practical, right, then you will not be able to understand. And see, when we do a practical, then you recall so many things from your theoretical part. So it's kind of a revision, David. So sorry for that, but yeah, I can't follow that approach. I'll discuss first theory, mathematics, then I'll come over here. So that's the approach. The thing is, at the end of the day, we are supposed to understand, right? And we are supposed to understand in such a way that we will be able to explain to someone. That's it. This is the understanding we all are supposed to get. It's not like we are trying to like write some research paper over here. We have to explain and then we have to utilize it. We have to understand in that way. Okay, so fine. Once saw the data set, send to once saw the data set, send to the CCP model. It's the same data set which I have sent, if you will observe. X1, Y1 that I have sent. See? Okay, now, so what we will do is, so maybe we are able to calculate the accuracy, we are able to calculate the prediction. I will be talking about a multi-class classification matrices because anyhow I had to discuss whether you are able to understand it or not. But yeah, so my responsibility is to talk about it in a class, at least for once, right? For all. So anyhow, I will be like talking about it, right? We can even build a better model out of this entire things. So I'll be talking about it. So when we will talk about a dimensionality reduction, right, technique with respect to a PCA, then I'll show you same data set with more accuracy, we'll be able to build a more stable models. That is also possible. So there are so many ways by which. So now my problem is if someone will ask me, okay, fine, so your model accuracy is like a 57%, closer to 60%. But can you please try to increase the accuracy a little bit, maybe by 5%, 10%, right? So even that is possible. I'll show you sometime, like in a class itself, I'll show you. Going forward for sure. Okay. So here, right? So here, this one is fine. With the help of maybe CCP alpha, I'm able to build a model and I'm able to get a train and test accuracy closer to each other. It's completely fine. Now what I can do is, so maybe I can look into some other parameters as well, because if I'm going to call my decision tree classifier over here, I have so many parameters. Criteria is equal to Gini. So it can be Gini or it can be entropy. By default, it's a Gini. Splitter is equal to best or random, right? It can be maximum depth is like not given to me. So maximum depth, till what depth it can grow. I can find out that as well, because I don't know like whether depth will be equal to 2, 3, 4, 5, 10 or whatever it is, right? Minimum weight functions and all those features. So how I will be able to get an optimized value of each and every parameter, because by default still it is taking, even though I'm just trying to control one parameter, right? I'm controlling just this parameter as of now. I'm able to control just with this parameter. Now, if I have to control other parameter, so maybe I'm supposed to find out the best possible value. So the way we are able to find out a CCP, right, by doing experiments. In a similar way, I can try to find out other values as well. One by one, one by one, one by one, I can try to find out other values and then I can try to test it, which is going to take a huge amount of time for all of us. So if I would like to reduce that timeline, and if I would like to utilize my computation power to find out an optimized parameter, I think that will be a better idea, because I have shown you CCP alpha with respect to one parameter. Similarly, so you can try to test it with other parameters one by one, one by one. But what we are supposed to do is, so we are we don't have that much of time that I will keep on testing with one parameters, and then I've just shown you so that, because it's the first time for all of you, people generally ask how to fine tune the parameter, how to find out the best parameter. So I have shown you, and yes, we are able to prove that result even with the random data set. We are able to prove that particular result, a kind of a data set about which I was not aware about, like even you guys were not aware about it. But yeah, somehow we are able to control those things. Now, so let's suppose if I have so many parameters and if I have to find out the best possible parameter, hyperparameter for all of these parameter which is given over here, what I will do, I can try to utilize maybe a random search CV or maybe a grid search CV. These are the libraries which is already available. They are doing a same thing that you have done while finding out the CCP, right? So what we have done, if you remember, and if you will be able to recall, so can I say that we were trying to pass a different CCP alpha values. We were trying to build a different models, right? And we were trying to append those different models. So we ended up creating this many number of models for a different CCP alpha values. Agree, everyone? And then we have tested all the models, right? And then we have plotted all the models. So this is the plot of all the models that we are able to see. This is what we have done, right? So we have created a multiple model with a different parameters, and then out of that we are trying to select one based on our criteria, right? So there is a library, so you can try to write your own for loop. There is no issue, and again it is going to work well for all of you, right? But you can try to use a grid search CV or random search CV, so it gives you some sort of added advantages in terms of sending a data while finding out the best parameter. So grid search CV means it will try to divide your entire data for the cross validation, and then one by one. So let's suppose it has divided a data set into a 5 sets. So 4 set it will send for the training, and then 1 for testing. Then another 4 different random set for training, and then for testing. So I believe theoretically we have already discussed this concept in my previous classes. Now let's try to understand these things in a practical way. So how I will be able to find out the best possible parameter at a time, not just one by one, because one by one we know we can do it, right? It's not at all a big deal for all of us. So okay, I can try to find out. So maybe I can try to write like a grid parameter, GRID PARAM. So PARAM, so just a variable, right? I can try to create a dictionary over here. a key value, right? So which parameter would you like to tune? So would I like to test this criterion, Gini or entropy? So which one is going to build a best possible tree? Okay. So criterion, maybe you would like to test, no issue. So we will try to test it with criterion. And here, so we can try to give what? We can try to give two options. So Gini and then ENTROPY. I believe a spelling is correct. Okay, if it is incorrect, then it will give me error. That's fine. Okay. So we would, I don't know, like whether I'm supposed to build a model with Gini or entropy. Which one is going to give me a better result? I'm like literally not aware about it. So what I can do is I can try to pass both the parameters over here. Okay. Now, what is the next parameter? Next parameter is splitter. So I don't know which one is going to work fine for me, whether it's a best or best, whether it's a random split is going to work fine for me. I literally have no idea. By default, it has taken last time best. So this was the accuracy I was able to receive, but maybe I can try to test it. There is a chances that a random split will give me a better accuracy. So fine, what I can do is, so I can try to write down a splitter over here. And I can try to give both the values. Best and random, RANDOM. Random I can try to give over here. Okay. Then maybe there is another parameter, maximum depth, right? So let's suppose I don't know what can be the maximum depth till what point I should allow my tree to grow, level 1, 2, 3, 4, 5, 6, and so on. I'm not aware about it, right? So by default, it will keep on dividing my tree unless and until it will not be able to reach out to the final classes. It will just keep on dividing. But if you remember, I talked about like a 20 number of data set in one, 22 number data, 22 records in one class and one record in other classes. So can I say that I'm supposed to stop myself over here? There is of no use to expand that decision tree unless I'm like unnecessarily I'm trying to increase the complexity. Agree, everyone? Do you remember that particular things which I have discussed, I think, in today's class? Yeah. So, okay. So I don't know, like what should be the maximum depth? That's completely fine. So maybe I can try to give a range of values. So range starting from maybe a depth is equal to 2 and maybe go till somewhere 40. Try to test it with 1. So it will test it with 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Then maybe I can try to decide. This is a key. This is a key. Now maybe we can try to decide. So minimum sample leaf split. It is, as of now, it is doing 2, but again there is a possibility that I can try to tune it, right? So maybe what I can do over here is I can try to give a range over here. So the range starts from 2, minimum is 2, and then maybe go till 10, jump off 1, right? Okay. Now there is another parameter called as minimum sample leaf or minimum sample split. We have chosen minimum sample split. Okay. So maybe we can try to like choose minimum sample leaf. Yeah. So minimum sample leaf, we can try to pick and choose, and then minimum sample leaf. And I can try to give a range is equal to maybe 1 leaf, starting from 1 leaf to go till 10 leaf they can create, and then maybe like a jump of 1. So these are the parameters I would like to tune. So what I can do is I can create one dictionary over here. So I've just created one dictionary and I have given a possible range that, okay, do one thing. So try to test it with all the range and all the combination. This is a compute heavy operation. And as you will keep on increasing your range, so it will keep on like increasing your computational power as well. Because what happens in this situation, let's try to understand. So from here, it will select, let's suppose, Gini. From here, it will select, let's suppose, best. Then 2, then 2, then 1. Build one tree, test it. Then Gini, right? Then random, then 3, then 3, then 2, then build one model. So combinations of all the permutation of all the parameters range that you have given over here, it will try to test it with that many number of combination. So it is going to test it. So you can just try to calculate how many permutations will be there. So more than 1,000 times it is going to calculate. So here, that is the reason. So it's a compute heavy operations. So yes, in some of your system, it is going to like take some time. So maybe what we can do is, so yes, this is the dictionary that we have provided. Invalid syntax. Where is this invalid syntax? In line number 1, criterion. Okay, it's a dictionary, right? So if it is a dictionary, so it should not be equal to. Okay, fine, done. Now what we can do is we can try to call grid search CV. If you remember, we have already done an import. And then we can try to pass what? Maybe we can try to pass an object of maybe a tree object we can try to pass. So there is a parameter called estimator. Now what is the estimator? So maybe we can try to pass any kind of a object. So let's suppose CCP I'm going to pass over here. And then parameter, so with which it is supposed to test. So what are the parameter? This is the parameter. So I can write parameter grid is equal to the variable that I have created in which I have a range of values. And then cross validation, in how many set it is supposed to divide a data set. So I can write 5, I can write 10. So in that case, 5 means 5 split, it will try to do horizontal split or row wise split. Random split it will try to do out of 500 record that I have taken. And then it will try to perform these operations. Okay. Now, number of jobs I can try to set. So here by default will be equal to -1. Let's suppose I have a multiple processor, multiple cores in my system. In my like a CPU, I have a 16 core, 32 logical processor. So -1 means occupy all the processors that I have. If it is equal to -1, if I'm going to give 4, so it will not engage all the processor because it is a compute heavy operations. And if you are running something in parallel, it will allow other things to execute and take a processing power from other processors. You can control your processor as well. How many processor you would like to engage? -1 means engage all. Okay. So here is the thing. Maybe we can try to store these things into a variable grid underscore CCP. This is the variable name I have named over here. And then I can try to do one thing. So grid CCP dot fit. And then I'm going to fit my X1 data set and then my Y1 data set. I'm going to fit over here. And I'll wait for like a couple of minutes. It is going to take. So in between, I can monitor my processors. Yeah, so as you can see, my CPU utilization is going high, very, very high, right? Yeah, it's like a GPU. Yeah, so on CPU, my entire core is full. Okay, done. It's done. Fine. So it's completely like done for me. And this is what on a range, it has been like it is trying to fit itself. And this is something it has done. So it was very, very quick for my system. Yeah. So here it has already tested with all of this range of the parameter. In your case, it may take some time, but in my case, I have a little bit high configuration. So it has like a completed. If I'm going to increase this range, maybe 1,000, it will take time for sure. So here it has already tested with all of these range. Now I'm supposed to find out the best possible parameter. That was my idea. That was the objective. That what should be the best possible parameter for maximum depth? Which one I'm supposed to do, Gini or entropy? What will be a best possible parameter for minimum sample leaf? What will be a best possible parameter for a minimum sample split? What will be a best splitter, best or random, right? So what I can do is, so maybe I can try to call this object a grid search object, which I have named as a grid search CCP, right? So this dot best parameter, best param, I can try to find out over here. Now, what is the result? So which one we are supposed to use, Gini or entropy? I think we have an answer now. We should use entropy. What should be the maximum depth we should allow? 15. What should be the minimum leaf we should allow? 2. What should be the minimum sample leaf? 2. What should be the splitter we are supposed to use? Random, right? Okay. So this is a best possible parameter. We still have some parameter. It's not like I have taken all the parameters. So you can try to take all the parameters. There is no issue, right? We have so many parameters, right? So you can take a range of all the parameters. You can just test it in this way, either individually, the way we have calculated CCP, or maybe with respect to something else. You can try to calculate. And then I can try to do one thing. So I can try to again train my model, right, based out of these parameters, because this is the new parameter which I'm trying to find out, which is different from the default one, right? So by default, it was 15. By default, it was none. By default, it was 1. By default, it was, I believe, none. By default, it was best, right? So here I'm able to find out the best possible parameters. So what I will do is, maybe I can try to create a new decision tree with criterion is equal to entropy. So criterion is equal to entropy. It's better to do copy and paste instead of typing everything. Maximum depth is equal to what? 15, as we are able to get. Minimum sample leaf is equal to what? 2. And then minimum sample split is equal to what? 2. And then splitter is equal to random. Yes. So this is a new tree that we can try to build. So maybe I can try to name it as a DT CPP new. This is the name which I have given. So fine. DT CPP new. Now what I can do is, so maybe I can try to like do this DT underscore CPP underscore new, right? Dot fit. What I'm going to fit? Same data, X1, Y1, fit it. Now model building is done. I can try to check the accuracy. So DT underscore CPP new dot score is equal to, so maybe I can try to check maybe training accuracy is 87%, DT CPP new dot score with respect to X underscore test, comma, X underscore train, sorry, Y test, Y underscore test is equal to 57%. So here we are able to do hyperparameter tuning. And again, we are able to see that, yes, there is a huge difference. So can I say that even after doing a hyperparameter tuning, we are able to get overfitted model? So people generally says that, okay, so if your like a model is overfitted, you are supposed to do hyperparameter tuning. See, I have done that. Some parameter we haven't covered. That's completely fine. It's okay. Whatever parameter we have taken. So we are just trying to type like do a hyperparameter tuning. Everyone says this line. So whenever I ask a question, right? So, okay, if you have a like a overfitted model, so what you will do? And they easily say that, okay, I'll just do a hyperparameter tuning. I say, okay, how? So they say that, okay, with the help of grid search CV or with the help of random search CV. In case of a deep learning, so I will be using a Keras tuner. And with the help of that, so I will be able to do a hyperparameter tuning. They think like it's a formula that they will be able to, they will apply and will work everywhere. And then I say like, okay, so in AI, so 1 plus 1 is never equal to 2. 1 plus 1 can be anything. So you can't say that hyperparameter is going to give you a best robust model. This is the example. This is not going to give me a guarantee that no, it is going to like give me a best possible model over here. Yes, so I believe, sorry, it's fit is not done. CCP new fit X test Y test. I have already done fit with X1 Y1, right? This is my training data set. I'm just testing it with the train and test both. Simple. So best model based on what? See, grid search CV will try to give you a best possible things. Again, I can try to run multiple experiments even over there. So I'll just show you. So cross validation is equals to, let's suppose I have taken 10 in this particular place. Just wait. Today's task, nice. So entropy 1713. Fine. Entropy 17, 1, and then 3, and then CCP. Are we able to get closer a little bit? Yeah. So the thing is, you will be able to control these things, and you will be like a very certain. Again, you won't be certain at all at any point of a time. So you will be able to control, and you will be able to estimate that what is going to work and what is not going to work, right? When you actually see a thousands of scenario, it's not like you have seen just one scenario and someone told you that it will work, so it will work. No, in AI, it is not going to work. It's not a mathematical calculation that you are trying to do. It's basically a random search that you are trying to do in case of finding out the parameter and finding out the relation between a data set, right? So here it's kind of a trial method. Yes, trial and error method. See why you are able to like get this kind of a result over here. There is a reason behind this one. What this grid search CV is trying to do. So grid search CV is doing nothing except it is trying to take this parameter combination of all it is trying to test, and wherever it is trying to like give accuracy, a best possible accuracy in between its own training and testing data. I'll tell you what is the data set it is and how it is trying to calculate this one. So here we have given cross validation is equal to 10. What is the meaning of CV is equal to 10? I think I have already explained you, but let me explain you once again over here. CV is equal to 10 means I have a data set. This data set I have. It will try to divide this entire data set, like I said, horizontally, right? So let's suppose I have like 100 number of records. So to try to create a record of set 10, 10, 10, 10, 10, 10, 10, such 10 kind of 10 number of set it will try to create, or subsample it will try to create. Now, when it will try to select this parameter, this, and this, it will try to pass first 9. Let's suppose, again, I'm saying let's suppose, if it is trying to going to pass like a first 9 as a training, then the 10th one as a testing. Then randomly it will select another 9 as a training and then testing. So can I say that it is trying to give you a best possible parameter based on the data that you have actually provided? It is not trying to correlate anything with respect to the final training data, a final like a data set that you are trying to utilize. Yeah. And yes, some of you will end up getting a Guinea as a best parameter. There is a possibility because your random selections data set is different. Mine is different. So that is basically possible. And that is like a pretty much possible at any point of time. Fine. So this is something that we can try to like understand, and this is something that we all can try to test it one by one, and then we can try to understand what happens actually inside this one, what happens actually within this entire things. So hope you all will be able to understand a little bit of it, right? At least. Shall we start random forest now? Maybe I can discuss a couple of more topics if you want. No, please. Next class, sir. Random search. Random search means what? Just change these things. Do you want me to write each and every line of code for you? So just do one thing. Try to remove this one, grid search CV, import random search, put it over here, then try to test it. Simple. There are other hundreds of libraries. And you will be able to find out one more thing, that we have built our own library for searching this kind of things. So, because we all understand what is going inside this one and what kind of operations it is trying to do. So even you don't have to use this grid search CV. You can try to build your own library and then you can publish it if you want. You can try to publish it over this one. You can try to publish it over PyPy. In case of a pre-pruning, what will be the best way to deal with it? So see, in case of a pre-pruning, again, pre-pruning is kind of again very random one. So what I generally suggest each and everyone is that try to check a certain parameter with this approach. Try to draw a graph. Try to see that what is a closest possible value it is trying to give you with respect to train and test. This is the things, right? So always try to check or compare with known and unknown data set. So if you are going to compare in that way, then this is a best possible a guess by which you will be able to build a stable model. So this approach I always suggest that, okay, so try to compare both at a time. Accuracy with this one and then this one. Grid search versus random CV. So in case of a random CV, so it never go through each and every permutations. It will try to select some of the values or permutation automatically, and then it will just go through it. So random search CV will be little bit less compute intensive as compared to grid search. Grid search means all, go with all permutation combination. Random search means go with couple of these. That's the only differences. Otherwise, there is no differences. Both are same in terms of processing your or finding out your a very first or the best parameter. Is grid search CV choosing the best parameter based on the accuracy? Yeah, based on the accuracy. But the problem over here is the data set that it is trying to check, right? So I have explained you CV cross validation. So in case of cross validation CV 10, when you are writing CV is equal to 10, what will happen over there? 9:1 ratio. So every time it will divide the data set into 10 set, 10 random split, 9:1, 9:1, 9:1. So even training is a part of the same data set and testing is a part of the same data set. So it's kind of a data leakage issue, and because of that, so it is trying to give you this kind of a score. So hyperparameter tuning is not going to give you a guarantee that, okay, you are going to increase a robustness into a model or maybe an accuracy. It is just going to give you some random parameter. Again, you have to work. You have to work with a multiple things. Maybe sometime you have to increase the range, decrease the range, right? And you have to keep on looking for a best possible parameter from your side. If it is not possible to increase the accuracy or maybe to stabilize the accuracy, then in that case, try to increase the data set for sure. What I generally suggest to everyone is try to increase the data set in the beginning. So instead of doing these things in a later stage, so try to arrange this data set and try to understand the relationship between data set in the beginning itself. We have a duplicate rows in data set. Is it affect the accuracy or not? Yeah, we have a duplicate data set. So again and again, it is trying to perform a split operation. So it is not going to affect much because it will try to keep the whole bundle into a same a set, because here you are trying to divide lesser than and based on lesser than and greater than values. So all these records will come on one side. How to quantify the larger data set? See, larger data set we always quantify with respect to experiment that we are trying to do and the complex relation that we have. So if we have a very, very complex relations, and even if someone has given me maybe 1 billion records, and if I'm not able to find out some sort of relation, that's a small data set for me, or a data set. So it's not like we should not say even like a larger data set or smaller data set. We should say data set with relation or without a relation. Because even if I have a small set of a data, let's suppose 100 record, 200 record, and it is showing a very good relations, it's completely fine. I will be able to build the model. It will give me accuracy for sure. So This is the intuition that we should keep in our mind. So what is the way should approach? Tuning hyperparameter or finding out the CCP? CCP is also hyperparameter, right? Have I told you that CCP is not a hyperparameter? I've just like shown you the approach that, okay, one parameter and then versus rest of the parameter. You can try to put CCP even over here. So that's completely fine. So it's like you can try to like do one thing in this particular place. So you can try to put CCP, and even with this CCP alpha, right? So you can try to keep even CCP alpha over here, and you can try to give a range of the values even in this particular place, because this is one of the hyperparameters. So what, like, it's not going to make any kind of a differences, right? So maybe I can try to take numpy dot a range alpha column numpy, because some fractions value we should give numpy dot random dot rand, and maybe I can try to give 20 over here. Try to understand a base part. The problems people with people is like they just jump. So this idea is clear, right, guys? How to correlate with other score precision, recall, ROC, AUC curve. Okay, I'll tell you. Just wait. Just wait. I'll give you a task, a small task, not a big one. But once I'll show you, and then I'll give you a task. Now CCP alpha range will be too high for 20 values. I'm trying to check. So consumption is very high. New office if उसी में iPhone gift कर दो सबको. Yeah, if you are going to sponsor, then for sure I will gift iPhone to everyone. Ketan is saying that new office if उसी में iPhone gift कर दो सबको. So if Ketan is going to sponsor, I don't have any issue. Looks like you are in new office. No, still I'm working from home, because since morning 8 o'clock, so like I had a class, and yesterday night, so it's been 1 o'clock by the time I was like back home from my office. So it was almost like close to 1 a.m. Then yeah, so I slept at approximately 3:30 or maybe 4 a.m. and then since morning, so I was not able to get a time to go to office. Then in between I had some meeting as well after my morning classes, so I had like a couple of meeting. So I've just like completed those things, and then in your class, so I'm again like taking your classes. Red Bull, yeah, I think 1 or 2. I like your schedule, sir. Hope I get the similar one. Yeah, you all can get the same schedule. Wake up till it's 4 o'clock again. Sorry, sleep at 4 o'clock, then again wake up at 8, and then again work for whole day, and then again next day. So yeah. It will take so much of time. It is like trying to take test it for all the hyperparameters. So, and CCP I have given, and a big range I have given for a CCP. My PC will die after doing this task. Yeah, for sure. So most of your PC is not going to work unless and until you're not going to do a hard restart. Maybe after doing a hyperparameter tuning. So generally we do this hyperparameter tuning on GPUs or it's like maybe on a high computational system. And that too, it's a 500 record. Just imagine, I have taken 500 record. My X1, Y1 is 500 number of rows, right? So I just have a 500 number of rows. Let's suppose I'll give you a 5 million rows or 5 billion rows. Then what will happen? Just imagine, just think in that way. May I know a GPU in your system? So I have like a RTX 2080 Ti. Rich kid. No, I'm not. So just because of hard work, you can say. You have SSD? Yeah, it's a 4 TB SSD. You can make an announcement in between. Okay, so yeah, I think we all know, right? So we will be able to get one best parameter values. We are supposed to put it and then we are supposed to test it. I think we all are aware about it. क्या बचा है पढ़ाने को? अभी तो बहुत कुछ है. Okay, in between I can't even execute a new things because a confusion matrix I would like to discuss with all of you. Confusion matrices for multi-classes, because here we have a multi-classes, right? So how to understand a multi-class confusion matrices, because for binary classes we all are able to understand that true positive, true negative, false positive, false negative, done, right? Again, multi-class confusion matrices is not tough to understand. It's actually very easy. If you will try to focus maybe for 5 minutes, 10 minutes, I think we all can understand. This will take time. I can't imagine daily routine. Sometimes even I can't imagine my routine. Okay, maybe I should terminate this thing. This will take time, and you all are able to understand. So I think purpose is clear, right? So it's better to like terminate it, or maybe I can try to execute it. So by giving number of jobs is equal to 4 or 5, so it will take a little bit longer time, but yeah, so it will be able to like do it, and my system will not even get slow. Okay, so fine. If I have to like find out the confusion matrices, right? So what we can do is, so maybe dt dot cpp and some model I can try to take cpp, and then new dot I can try to do like predict over here, and maybe for x underscore train I can try to predict. So this is the prediction which I will be able to get. So prediction I will be able to get over here, and then I can try to call confusion matrices. If you know, if I have already done an import, so here y underscore train dot comma predict, I can try to pass. This is the confusion matrices. How many classes do we have? 6. Are we able to get like a 6x6 matrices? Yes, we are able to get 6x6 matrices. Now, in this row, we have 0, 0, 0, 0, 0. Over here, we have 0, 0, 0, 0, 0. Any reason? And we are able to get some sort of a numbers in between. So any idea? No? Due to pruning, maybe because that class is not available. Yes. 0, 0 we are able to get because that class is not available. See, I have taken a test data for like finding out the prediction one, right? Or maybe I have taken a training data set. Now over there, right? Over there, all 6 classes was available. If you remember, I have selected a train data set where 6 classes was there. Then I have created X1 and X2. I have built a model based out of X1 and X2, right? So maybe some sort of a classes was not available over here, and I have given some extra class right at the time of prediction. So because of that, it is giving me 0.0000000 result. Any idea what is the meaning of these numbers? Anyone? Look at only the diagonal values. No, even if you will look at only the diagonal values, right, you will be able to see a zeros. Okay, so now from my side, task is right. I think yeah, we have discussed a lot today, so I think that will be enough. So task for you is this sheet will be uploaded, right? Next class, first 5 minutes, I will give you a chance, just 5 minutes, right? Whoever is going to explain. So I'll give you a chance to explain this one, same matrix to me, right? Exact same matrices from my sheet, right? Same matrices to me. And then I will give my explanation. Simple, right? So yes, be ready, try to understand. I'm looking for a neat and clean explanation. True positive, true negative, false negative for all the six classes you are supposed to define and you are supposed to explain, right? This is the only task that I'm giving you this week, no other task. Plus, I have some announcement for all of you, as I said in the beginning. So the announcement is, so some of you would like to connect maybe in one-to-one mode, right? Some of you would like to so can I explain the task in Hindi? Yeah, you can explain task in any languages. So most of the original languages I'm able to understand, at least from India and North and South both. So yeah, you can use any languages. I don't have any issue. Means my incoming is good, outgoing is not that good in all the with all the languages. So yeah, hope you are able to understand. So okay, yeah, even with Odia. So I was in Odisha for like Odia, Bengali, all those languages. Telugu I can understand like a little bit, like 30-40% I can understand. Marathi, so yes, I can understand because I've been in Pune as well for a couple of times. So I always like Kannada, so I'm already in like Karnataka since last 4 years. So at least I can understand whatever you will speak. Maybe I'll not be able to like I don't have that speaking fluency, but yeah, I can understand. Okay, like I said, most, not. So okay, now let's try to understand this one. Here, okay, sorry, I was trying to say something. So yeah, most of you would like to connect with us for maybe internship, right? We are giving you responses, we are giving you a reply over the mail, and most of us would like to discuss your profiles, your resumes, your problems, many more things. Now we have two options. Option number one is that we have decided that we will be available, right, just for this one. So where you can discuss anything, any like personal things, any projects, anything that you would like to discuss, any suggestions, any advice, resumes, whatever you want, you can discuss. First of all, by sending a mail. Now, here, if you are going to send a mail, so for sure my team users to respond, and then they will be able to give you a reply. Second option that is good. So this option is already available. I think we all are aware about it. You all are sending us a mail, and then we are sending you a reply. Plus, support team is already there, right? Plus, we have a doubt clearing. So where you are connecting with Ironode team member. From tomorrow onwards, I'm going to start one more initiative so that it will be easier for all of us to communicate, and it will be easier for all of us to get a clarification, maybe on a career level, resume level, or whatever you want, any business use cases or whatever you would like to discuss about the startup idea, whatever you want. I don't care about it. Simple. Well, we can discuss about it in one-to-one basis. So from 1 p.m. IST to 2 p.m. IST every Monday, I will be available. Then Tuesday, Chris will be available. Wednesday, Sunny Bhavin Chandra will be available. Thursday, Swarganshu, Paul will be available. Friday, Avnish will be available going forward, starting from tomorrow onwards itself. So we will try to send you one single Zoom link, right? So that Zoom link we are not going to change. That's a plan, right? That will be updated inside your dashboard. So we are not going to send you any notifications or any mails for that. Whenever you feel that, okay, fine, so you have some doubt, it's 1 to 3 p.m. actually, not 1 to 2. So for 2 hours, and again, if we are in discussion, so unless and until we are not going to close it, we will not close our discussion. Very simple. So even if it is, we have to extend the timing. So this is the base timing that we are trying to keep over here, so that it will be easy for all of you to connect with us, because you are already connected with the Skype, you are already connecting with a support team, right? You are already connecting over a mail, you are already participating in an internship. So let's suppose if you are facing any kind of a hurdles with respect to internship, maybe with respect to a project, maybe you don't know how to talk about myself in an interview, right? Because we all have some sort of a doubt, we are trying to do a preparation, right? And yes, we need some guidance, some suggestions, or maybe some sort of help or assistance we are looking for. In between 1 to 3 p.m. every Monday, I will be available. So tomorrow I will be available. We are just scheduling this way. Every Tuesday, Chris will be available for 2 hours, right? Every Wednesday, Sunny will be available. Thursday, Paul will be available in daytime. So I believe it will be your lunchtime. I've kept this particular timing because for most of the working professionals, so it will be a kind of a lunchtime. So let's suppose if you would like to discuss. So yeah, based on the person's availability, this is the person's availability I'm trying to keep as of now, so that even I will be able to connect, Chris will be able to connect, Sunny will be able to connect. Sunny is very, very good in deep learning in an ops side. Paul is very, very good in terms of computer vision, NLP or ops side, right? Avnish, super developer, right? Chris and me, I think we all know about each other, right? So that's completely fine. So I will make these people available in between these time stamp on this date. So you can feel free, and I'll just upload one Zoom link. Like I said, there is no recording we are going to keep for this one. So this session we are not going to record at all, so that you will be able to discuss your resumes. You will be able to talk about your profiles, right? It will be a kind of instant one-to-one. Very simple. It's like doubt clearing session. We are trying to record it, right? But this session, we are not going to record it. We are not going to upload it inside your dashboard. This will be a discussion between you and your mentors. Very simple, right? So we are not going to record it. And yes, we'll update a Zoom link. You can try to join, and yes, in our scheduled time in between 1 to 3, and then we can try to clarify, we can try to handle this one. Sir, 1-to-1. Yeah, so it will be 1-to-1 itself, right? There is no recording. So let's suppose if 2 or 3 people have joined, so we can discuss within 2 hours with 2 or 3 people or 4 or 5 people, and then it's done. And it's a kind of a continuous one. So it's starting from tomorrow onwards, just to give you a better connect, a better services, so that you all should feel motivated. Whenever you are feeling demotivated, come and join. So whenever you are looking for guidelines or something, whatever it is. So here we are not keeping any kind of an agenda that you should just ask a doubt or something. No, you have to discuss a resume. No issue. Come over here. We'll close it then and there, right? So I'll not even ask you that. No, I'll discuss your resume after like a 6 month or maybe after the class or something. What about Wednesday 10 p.m.? Everything is as it is. We are not making any kind of a changes. Your doubt clearing session will be as it is. Your regular classes will be as it is. This is the additional things which I thought of giving to all of you. So don't worry about iNeedOn never removes the existing things. iNeedOn always adds a new things, right? So don't worry. Plus, if you are in Bangalore, point number 3. If you are in Bangalore, or if you are traveling to Bangalore anytime, today, tomorrow, after 1 year, or even after 5 years, right? So you all can feel free to come to an office. Again, I'll make a big announcement actually. Chris, as of now, he has made a small announcement just about the office, right? But there are many new things which is coming up for all of us, right? And for our entire world. So we are going to set up a kind of a lab. I'll talk about it in a later stage. Yeah, I'll discuss about that thing. So it will take like a 3 month of time. We have started building it. So as of now, we have started working from the office. So here, face to face, right? So if you would like to connect, if you would like to discuss face to face, so most of the time I will be available or Chris will be available. If me and Chris is not available, right, because of some meetings, so we go outside a lot. So my entire team will be available. You can sit with them. You can work with them. You can be here even if my team member is not there at night 2 p.m. If you're not able to get a place, a peaceful place where you can sit and you can work, if you are facing any kind of a issue with respect to internet connectivity or anything, maybe tea, coffee, and all those things, right, in between. So yes, all those facilities are available in our office, and you all are invited in our office. And yes, you can work over there with us for an infinite time. This is an option which is available to all of you, right? And yeah, so I'm not asking you to contribute in our project. I'm just asking you, I'm just like talking about a platform which I'm giving to you. It's not about an internship. So don't try to take in other way that it's an internship and you have to work in our project. Not at all. I'm just giving you this option. I'm not just giving you this particular option so that if you are not able to get a comfortable place, if you're not able to find out an ambience or environments where you can sit, work, or maybe study, explore, like with the like-minded people, you are welcome to our office, right? We all will be available. And actually this was the pattern we were already following without before a pandemic. So it's not like this is something new that we are trying to make as an announcement. This is actually a pretty old thing for us. This was actually available. So and many people, I'll tell you, like hundreds of people, they used to come to our office. They will sit inside our office till 4 o'clock, 5 o'clock, 5 a.m. Right? They will just work, experiment, work with my team. And even if like I don't ask anyone to work for our project, simple, because you are voluntarily you are coming over there. So I can't take any kind of a commitment from your side. But still they ask them, okay, fine. So like, is there any things where I can contribute or something new? You can give me some new challenge or something. And yes, people use this to work, and just you can imagine. So if you are working in that environment, it simply means that you are able to see, or you are able to like, you're actually like before even getting into industry, you're able to see our industry, right? So this was there. And yes, because of pandemic, so we were not able to continue because office was closed. I can't invite everyone in my house. House is not that big. So now office is open. So I think you all can come. Yeah. Now office address, I think it's already updated on a Google map. If not, so I'll just tell you what is the office address. It's very easy to find out. Brigade Signature Tower, right? So this is the tower, and from very far, so you will be able to see this tower, right? In night especially, you will be able to see this tower. We are available in this office in 11th floor, tower B. But security guard will not allow you to enter unless and until you don't have a prior permission from our side. So please try to send us one mail, because there are many people who visits, right? So we try to either personally you have to call, or it will be better. So you can try to drop us a mail. So let's suppose tomorrow you have a plan to visit. Once you will come, so we'll create your visitor pass. And once your visitor pass will be created, then you are not supposed to drop a mail. So you can come and sit anytime, 2 o'clock, 3 o'clock, 5 o'clock. Otherwise, you will face some issue. Right? Maybe you'll have to call, and then again, some person will come and then they will take you in, or something like that will happen. Yeah. So each time pass is not required. Once we'll release for once. And yes, you're not supposed to come and disturb everyone in our office. So when you are coming, so yes, you can come, you can meet, you can sit, and you can work. That is allowed. Disturbance is not allowed. Simple. And bugging everyone is not allowed in our offices, because like everyone loves a peaceful life, right? So peaceful environments and everything. So yes, can I visit in night time and work over there with you? It's not like I will be available if you're coming. See, it's not like I will come and teach you. That's not a teaching place. I'm giving you that option so that you can come, work, sit, and in a comfortably over there. It's not like I will sit with you. No, that is not possible because I will be having a back-to-back meeting. So it's really impossible. I can't give a commitment that I'll sit with you. No. Yeah, we can meet, we can discuss, and my team will be there, right? My entire team will be there. So again, it's not like my entire team will sit with you and then they will just spoon feed each and everything that do this, do that. Again, this is not going to happen, and this will be a practice. We will revoke the past. It's very simple. This is a option which is given to you, so you should take an advantage in a positive way, right? Not in a way that you will disturb other. Like I said, in our office, no one likes a disturbance. No one. So simple. It's like a corporate office, right? So you're not allowed to disturb anyone. Come, sit, work, have a coffee, tea, and yeah, contribute, have a healthy conversation, but no disturbance. Simple. That's not fair. Yeah, so you want to disturb, come and disturb. So yeah, I'll not allow in that case. Simple. So that's not my policy. एक ब्रांच पुणे में खोल दीजिएगा प्लीज. Yeah, so we'll think again. So there is no plan as such, but yeah, I don't know what will happen in future. So there is a possibility. Is there any person to help if we have any doubt in work? No, don't think in that way. It's not your doubt clearing session, right? We have given you enough amount of option to clarify your doubts. Now some people comes and say that I'm not able to execute an Anaconda prompt. Now if you will ask us, come and sit in office and then ask us that I'm facing an issue with Anaconda prompt, right? I think we'll simply say no, we'll not fix your issue. Even though we know we can fix your issue within 2 minutes, right? We'll simply say no. Why to fix your Anaconda prompt issue in our offices? For that, you have a mail support, you have a Skype support, you have a doubt clean sessions, right? Like I said, it should be a productive one. When you are coming to an office, you should give a respect and value that what you will be able to get, right? Simple. So straightforward, my team will tell you, no, I'm not going to help you out. So that is not going to like a work, because office means you have to work. Simple. Yeah, so don't come and ask my Anaconda prompt is not working, my Python installation is not working, my Pandas is not working, I'm not able to import these libraries. Okay, for that we have a solution. We have given you an option, multiple options we have given you, which is not available, I believe, with other platforms, right, where you can connect people to people. So I think there is a different things, different provision which we have, and we should respect each and everything. Yeah, right, everyone. Sit to work on our task and leave, right? Yeah, we can come sit work on our task. Even you can discuss. See, everyone loves a healthy discussion, and especially in our team. So if you will discuss something innovative, right? If you'll say that, okay, fine, so maybe this is a new thing that we can build, or this is a new innovative solutions that we can build, right? So everyone will respect you, and then everyone would like to like contribute in that one, and then you will be able to get even some sort of a help in terms of fund to like arrange if something is something you're looking for in terms of devices or some like a asset, right? So company will try to release if it is like within the limit, so that is possible. But if you will come to office and then unnecessarily, if you're trying to bug in very small things, you will say this assignment I'm not able to solve, that assignment I'm not able to solve. So office is not open for that purposes, right? It's for innovation, it's for a development. So if you can come with that particular mindset, then you are welcome. Otherwise, like I said, so we have a full right and authority to revoke a pass, and you should not feel bad in that case. It's just like we are trying to maintain it, right? So that a person who is really would like to like leverage those opportunities, those platforms, they can leverage it. Office is too far. I mean, like it's in within Bangalore city, so yeah, Bangalore is a little bit bigger. We also resume the task creation by our fellow peers like MLflow 1. Can we also resume the task creation by fellow peers like MLflow 1? I think we have already discussed, right? MLflow and this one. Yeah. So fine, guys. I think I have already made an announcement that from tomorrow onwards, means Monday to Friday, for 2 hours. Me, Chris, Sunny, Avnish on a scheduled day. So we will be available. Link will be updated inside your dashboard. We will not send you a regular notifications for that. And you should not even ask for like a recording one, because this session is planned in such a way that you can even discuss a personal thing, you can discuss about your resume, you can share your screen. So those recordings should not go as a recordings, and we will not push those things as a recordings. So we are not going to record it at all. This is basically an one-to-one discussion between you and your mentor. Simple from my own side. Yeah. So that is the reason. So we are keeping this discussion so that, let's suppose maybe something you are not able to clarify in doubt clearing, maybe you are like not able to get a response, or maybe you are facing some issue with your internship, you are not able to understand what to do next, what I have done. You need someone to discuss those things with you. Yeah. Just for that purposes, I think we all will be available. So for sure, you would like to connect with the Chris, you would like to connect with other team members, right? So keeping these things in mind, so this is an option that we have given to you. Yeah. So try to leverage this option, try to utilize these things as much as possible. At the end of the day, we all have one simple goal: transition. An easy one, not a hard one. I want to work in iNeuron. So yeah, prove yourself. Because like Chris has mentioned in his video, so we never go ahead with your certificate, degree, or whatever you have done. We always see your work. That's it. Nothing else. In our team, so yeah, everyone just look after those things. So this is how we have created the entire iNeuron team. Okay, so fine guys, thank you so much, and see you again in my next class and tomorrow for sure. For fresher, how much salary? I think it's a 3 lakh LPA, which is already mentioned over there, right, in your LinkedIn post. And again, so you're not supposed to wait for 1 year to get a hike. So here hike happens randomly and frequently. So within 2, 3, 4 months, 6 months, based on your performance. So here we don't follow MNC culture. Simple. Just try to think in this way. And again, hike means I'm not talking about 10-15% hike. It just depends upon only one thing: your performance. That's it. If you're not performing, it will be as it is. And it may be decreased as well, possible. If you're performing, it can be anything. So this is how we work. We have this evaluation criteria, and we are very good with like observing things like, okay, fine, so who is working, who is not working. We have that kind of a hierarchy in our company, so we can maintain. Decrease part was OP. Yeah, that's true, right? So it's completely fine. People say that. I was just looking into a comment. People are saying that no, base will be 4.5, this 5 and 6. Okay, so those who are giving 5, so here people are able to get more than that in 6 months itself, right? Out of 6 months, more than that they are able to get over there. So from 5 or from 4, if they have to reach out to the 5, they have to switch again into another company, or maybe they have to wait for another 3 years to reach on that level. Here it's different. Tomorrow no class, right? No, there is no class tomorrow. It will be a discussion. It will be a discussion, so you can come and discuss anything. There is no agenda fixed, right? So it will be a discussion between you and your mentor. I think I have already gave you a name. So fine with that. Thank you so much. Do you mean performance in a course and internship? Know your work. Even if you have not done an internship or something, but if you are able to prove yourself by showcasing your work, we don't have any issue. At the end of the day, work is the only thing which matters. Whether it's coming from your internship or task, doesn't matter. Or maybe from somewhere else. Current client has given an opportunity to work on MLOps. Do we have any pre-recorded sessions so that I can learn in next 10 days? Balaji, everyone has already implemented MLOps. Last time, if you remember, or if you have attended, many people have given a demo on MLOps. They are from your class itself. So I think you can take a help from them. You can search, can connect with them. You can take a help if you're facing an issue, and your issue will be resolved easily. Plus, in your dashboard, plus we have given a community session, mega community session over there. These things was already available. Yeah. So fine guys, with that, thank you so much, and see you again in my next class. Thank you.